All right. Hello, hello. Um, can you hear me good? Yes? All right. Nice. Well, first, I'd like to thank everybody that has been behind the scenes. So, please, a round of applause for the people that are able to put this together. And yeah, so thanks for coming in. My talk is going to be around how to solve the cold start problem by embracing open graphs. I'm going to keep it a little bit more level down. I'm not going to dive too deep, but my intention really is to reflect, take a look at how the landscape has been building up through the past couple of years, 40 years and so, in Silicon Valley, reflect where we currently are and where the industry is going, specifically with Web3. So, the cold start problem. Fundamentally, where we all begin as startups, it's hard to build, right? If anybody here already has 100 million users, please get up and leave. This probably won't be for you. So, essentially, the starting point for everyone when we build something, there's a lack of value, right? And Andrew Chen, the general partner of A16Z, has written a book about this because it's important for everybody to know. He also talks about network effects. I'll be covering that as well. And I want to dive into the open graphs as well. So why is this important? Everyone faces it, right? But if we take a look at the current landscape of the industry, and by that I mean the most valuable companies in the world, we have the value capture with graphs, right? So if you think about Google, the knowledge graph. You think about Facebook, the social graph. And if you think about Amazon, the product graph. And altogether, you have a massive value capture of more than 4.8 trillion. And all of these graphs have been closed. Now, we are beginning to see more and more adoption with open graphs. And I'll get a little bit later into how we're going to be able to tap into these opportunities. So let's begin with defining what a graph is, right? Just very simple. We have a structure, and on that structure, we have objects and their relations. Very simple. And within those graphs, there are specific types. Like I mentioned, the product graph, the social graph, and the knowledge graph. Now, the reason why these graphs become valuable is because of network effects. In simple terms, the network effects are when someone joins the network, it becomes more valuable, right? Think about the phone. It took a very smart person to create a phone, but it takes a genius to sell one. Why? If you're the first person that ever gets a phone, who are you going to call? There's no value in the network then. Fast forward, you have billions of people using the phones, and the value of the network is apparent. So again, tying the dots together, network effects and graphs together, a lot of value that you can capture. So the faces that everybody knows here, I'm only gonna pick on Web 2, not gonna pick on Web 3. You can see how these people started, very cold, and at that point, it was the only way, right? So how they tackled this, Facebook, famous for starting only in Harvard, getting people into the network. Now all of a sudden, you had a social graph that you could tap into, right? Tinder, they started throwing parties in universities. Who would have wanted to attend one of those? And essentially, within their network, now they had people that you could date. No one's gonna want to join a dating app where there are no options, right? So Airbnb, being famous, they're founders for knocking on doors, having people list, and as well encouraging people to rent from the platform, right? So that there is the graph being built up. And Uber, who has been seeing the series on Netflix? Anyone? All right, I just started yesterday, so there was a large capital injection in order to begin building the graph of transportation. So in summary, it took a very big effort to reach escape velocity and grow those network effects. All right, so we can see a relation here, right? As network effects go higher, the cold start problem goes lower. Just like that. So let's touch now into the role of open graphs, because the examples that I've been giving are, the majority of them are closed graphs, right? Permissioned, they have walls, wall gardens. They're not designed for anybody to just tap in and make use of that data as much as you want. And essentially now with open graphs, we are able to have more momentum. We're able to build with innovation because we're not starting from zero. You don't have to go knocking on doors. You don't have to have massive injections of capital anymore to begin with a user base. You don't have to have large amounts of capital in order to incentivize people. So it is a different playing field in which we currently are and are heading towards. So think about when you're starting something, right? We all have some decisions that we need to take into account. If we are beginning a startup and, well, we're going to need some users, we're going to need a network, it makes sense to build where the users are. It's more attractive, they can be more engaging, and essentially you don't have to really convince them too much to run down a mile in order for them to download your app and to begin trying out a new home, right? So why reinvent the wheel when there's a lot of wheels up and running? And the most exciting part here, right? So we already have very well developed graphs, like I mentioned before, the social graph and so on, that they have captured a lot of value. However, now we can build on top of value. You can add and take that value further by tapping into open graphs, because as a developer, you have the freedom to use that data as you want. You have composability, you have modularity, and you're able to just experiment. So let's take a look at some examples that have used open graphs. I'm many of you might be already familiar with Mastodon, Threads as well, Instagram. Now, ActivityPub is actually the social networking protocol. It's an open graph that is below of both of these applications. An asterisk for Threads, because they're supposed to go with ActivityPub. That's the promise. But so we're going to see that hopefully in the next couple months. But essentially, the whole value add here is if you are tapping into an open graph like ActivityPub, now you tap into the network of both Mastodon and Threads. So for a minute, imagine that you want to build your own social network or an app that you want to tap into these users. Have a little birdie there. Now, everything is interoperable. It is accessible. If I want to have a social app and post on Mastodon, I'm going to be able to see it on my Bird app. I'm going to be able to see it on Threads and vice versa. So this opens up a new landscape of tapping into network effects, tapping into people without them having to start from zero and without you having to start from zero. This is a very classic example, right? The EVM, people launching layer 1s, layer 2s, social graphs on Ethereum, and this is going to continue. But let me just, for a second, imagine where we would be if every time a new layer 1 spins up, we have different wallets with different formats, and we have to start from zero. And this is one of the most exciting graphs that are coming up and being developed, which is the financial graphs. So again, in blockchain, we have a lot of advantage. We're still young, right? Ethereum has been around for what, around 9-10 years soon. So do we talk about Cosmos here? Cosmos ecosystem? This is another great example of tapping into network effects, having interoperability between ecosystems, and the users being able to engage seamlessly. This is one of the most recent examples that many of you might already be familiar with. Farcaster, right? By tapping into the extended Open Graph standard, which Facebook developed, they were able to develop frames. So essentially creating mini apps that have a lot more flexibility inside of the Farcaster protocol. And we're starting to see a lot of crazy stuff being done there. So a very good example. Oops. So this is the approach that we are taking at Timeless, which we're building a Web3 wallet, right? Leveraging account abstraction, and in very simple terms, we are tapping into different open graphs to provide a seamless experience within the same place, right? So the starting point in Web3 is your wallet. You have open graphs. You have means of communication that are open as well. Why not put that all together? Right, so let's talk about the potential here. The closed graphs, for more than 4 trillion in value. And the open graphs that are growing, we're moving from renting our data in the internet to owning our data in the internet. When we own that data in the internet, that lies mostly on open graphs. It's the data that we can control. And one of the most interesting parts of this is that when you have a closed graph, it's singular, right? Remember ActivityPub? You have different applications. Now you're tapping into an aggregated pool of data where multiple open graphs are able to, so you're able to put together multiple open graphs instead of just building on top of one. So essentially, now we're able to tap into use cases that even the builders of that first open graph didn't even think about. So, the key takeaways: open graphs, best friends for network effects. We don't have to start slow, we don't have to start cold, and it's ideal to build where the users are so that we can get up and running. And as the network effects go up, cold-start problem comes down. All right, so for everyone that stuck around here, I've just created a little POAB for you guys. Very thankful for supporting, very thankful for your support. I'll be here if there's any questions. I think I still have a little bit of time, so if you want to connect, you can find me here as well. And thank you.
Well, hello everyone. Welcome to my session, NFTs as relational databases. My name is Rob. We'll do an intro in a second, but first I want to get to the problem statement. What we're trying to do is we want to have data records that relate to other data records, all on chain and gas efficient. That's the problem to solve right there. Because if we can do that, we can extend them all the way down. So if A relates to B and B relates to C and C relates to D and so forth, then we have a solution. So my name is Rob Green. I'm currently a co-founder of Runic Labs, a VC-backed crypto product development group. I came off of recently 4 years at Coinbase. I got there after developing with a team a product called Paradex in 2017, which was a DeFi exchange on Ethereum mainnet. In the past, I've worked for companies like IBM, but I've spent a lot of time being an indie game developer over the years, and I'm a lifetime computer and technology hobbyist. Ultimately, I don't think it matters that much. I just felt like I had to say that, but the concepts matter far more than the person, so let's get into it. So basic glossary here for what I'm going to talk about today. I'm going to go over it with a little bit of detail, even though some of the stuff you're going to roll your eyes and say, Guy, I know what a 721 is. That's fine. But the primitives are important. So ERC 721 is the NFT standard. It's what many NFTs are today, and if they're not that, they're usually an ERC 1155, but an 1155 is actually only somewhat considered an NFT standard. It's a multi-token standard, and more on that in a minute. Another really interesting one, and I bring this up because I get asked about this one a lot, is ERC 6551. And if you're not familiar with 6551, it's an NFT-bound account standard that I'll cover in a minute too. The next term is metadata. We all know about NFT metadata. I'm going to go ahead and call that a record today as I go further in, but it's data associated with any one of these three things. And then a relation, we're going to define a relation as a record with a to-one or a too-many relationship with another record. So, starting on ERC 721s, these things are old. We've had these since 2017. These were pretty much the foundation of the big NFT boom that happened. But the two really unique items or attributes about ERC 721s is that they are a unique address with metadata. And by unique address, I don't mean just the contract address. I mean the uniquely addressable piece of information. So if you take the address plus the token ID, that describes a unique piece of data, which is a metadata URL, which leads you to metadata JSON, right? And so in my example on the second line, if you see well, it's Taco Foods written out in hex, okay? Taco Foods, token ID 55. If we look that up, it would take us hypothetically to mydata.com/55.json, which would have something hopefully unique about token ID 55 at that address, right? So that's a unique piece of data. The other thing that's a primary attribute about 721s is they have ownership. That if you take this little bit of solidity here, cast it to a 721, Taco Foods owner 55, and ABC123, that address owns it, right? Now, when I was first working with 721s, I had people saying, well, when are you going to do 1155s? Because 1155s are better. 1155s do more. 1155s they're just 721s with batch transfer functions. But it turns out that's not exactly it. I don't think they're going to replace 721s, and I don't think they're truly a superset of 721s. I think they're a little bit different. The big thing about 1155s is that they are a balance of a token ID for an address. They don't use the word address anymore. They call it a count, and there's a good reason for this. I assume, is everyone here familiar with the ERC20s? Super basic, right? An 1155 is more like an ERC20 for each token ID, being that you can give a balance of to a user. So I don't give you 1, I can give you 5, right? And so if the Taco Foods contract is an 1155 and we check the balance of account ABC123 for token ID 55, it'll say your balance is 4, right? The big thing about 1155 is there's no owner of. That's not a standard function on 1155 because instead there's just a balance. And that has implications when you want to get into data relations. One of the biggest things is that 1155s have a single metadata URL for the entirety of a token ID. Okay, so there's not like if ABC123 has 5 and DEF555 has 20, they have the same metadata. That first user's 5 can't be different than the other user's 20. But 1155 is super awesome at what it is, right? One of my favorite use cases for it are commodity items. So say you're building an app and you want to have something where you're issuing gold, silver, some kind of monies, right? Bricks, let's say, in some kind of app. If you can see, this would be an example sort of table that you would have in an 1155. And so we can see that there's one account, 0012, that has token ID 5,000 of token ID 5, 12 of token ID 32, and then this other account has 33 of token ID 32, and then these other 2 accounts, say this is some, let's say token ID is like the in-game money or currency of some kind, and this account has 821,000, and that account has 5.9 million. It's really, really awesome at this because with one call, you can transfer millions of the quantity of that token ID to another user, and that's something that 721 just doesn't do, right? So for this use case, it's incredible. But if you've heard about 6551s, and there was a lot of hype about them in the last year where people were saying, what about 6551s? These are gonna enable everything. They're gonna enable all the composition, all the relational data, all these things. Yes and no. 6551s are also amazing, and they're very, very cool at what they do. Ultimately, a 6551 is a proxy account owned by a 721. For every 6551, there is a 721 underpinning it. And the way that works is that if Taco Foods, let's say, is now a 6551 contract, I can call it, and if I own the 721, one of the token ID at the 721 that creates that address, I can execute code on chain on behalf of that address. So the other contracts see the call coming from that 6551 account address. And that's super powerful because that makes it so that if you own a 6551 account, again, underpinned by 721, if you own that account, you can own a slew of NFTs, you can have a balance. Let's say you want to collect a certain bunch of NFTs or something like that, and then you want to sell them. You want to sell them or transfer them to somebody. You don't have to transfer them one by one. You can sell the token ID at the 721 that owns all of it. And that's something that you can do actually fairly trivially with a 6551. But there are some considerations you need to make if you want to use a 6551 in this way. If you want to have a relational hierarchy with that, you're going to have the 6551 721 problem, meaning that the first 6551 that you own, you have to actually own the 721. And if you want that 6551 to own another 721, and you want and that owns a 6550, that controls a 6551, you've got multiple hops to go through to assert the ownership of that. You have to have knowledge of both. So ultimately, 721 is still the primitive in a 6551. And a lot of the things that you want to do with hierarchy, you can actually do directly with 721s. 6551s also are a little more difficult because with a 721, you'll know if you go to the Etherscan or whatever and you look at the address, you can find, well, what collection is this, right? How many were issued? I can find out things about it. But if all you know is the address, the account address of a 6551, and you don't know anything else about it because that's what you're going to have your app own, you don't really know what collection it belongs to. You need more data than that. The address alone doesn't tell you quite enough about it. Also, making contract calls and front ends on top of 6551s is another layer of development that you have to do to be able to handle all the proxying through and all that sort of stuff. So let's imagine 721s have evolved a little bit for a second, okay? And instead of thinking them like, you know, I know a lot of people think of 721s as like PFPs, like all that is some art somewhere on a server. But let's get rid of the idea for a second, and let's think of each 721 as an address, like a table with a schema, okay? And then for each token ID, let's make that like the primary key. And instead of metadata, let's just call it the record. But as you can see, off-chain data, off-chain JSON is a problem. So if Taco Foods, again, is a 721, token ID 55 is at this URL, I have to externally, I have to go off-chain, and I have to go look that up, and I can go read this JSON that says that this relates to FF11, token ID 8. Then I have to go back on-chain. I have to read about FF11, token ID 8. I have to go look that up. I have to go off-chain again to get the data. This isn't that helpful, right? If I want to write it, or if I want to write a really robust on-chain app, there's too much that exists in servers that are outside of what my transaction can even do, what my contract can do. I also would then have to add a server to do that. So if we can bring the data on-chain, we can solve that atomicity problem. Okay, so let's imagine this is all on-chain. So we have a table here of data, and the metadata, imagine that there's some on-chain representation of this. If I can read in a contract that Taco Foods 55 relates to FF11.8, and FF11.8 has this data in it, I can now write a contract that says, hey, if you have FF11, any token ID on it, I know what the metadata scheme is, and if your happiness is over 10, I'm going to award you with something, or we're going to be able to perform some action. Right? And so now these relationships actually become meaningful because all this is done on-chain, and we can also have data integrity. We don't have a situation where some server's offline, someone changed data, someone pulled the plug. These relationships can be created with rejections if, let's say, there's a violation or something like that. So you're guaranteed to have data integrity. So real relationships start to look like this. A 721 address and a token ID relates to another 721 address and a token ID. And once you bring the metadata online, this all starts to become usable. So how do we go from just talking about it or having some like esoteric sort of code that we wrote that doesn't matter to anybody else and make this usable, make this interoperable? First, we have to ask ourselves, what does it mean to have on-chain metadata? What about the ABI for interfacing between contracts that have on-chain metadata? And how do we discover other contracts and interoperate between applications and contracts? And if you start with some definition, just some definition of a metadata schema on-chain, given this one, this is a very minimal form, but with this is complete enough to be usable, right? So if I define my metadata as having an array of these, and each one of these is an entry, and so this represents a field. Each field has an ID, a field type, maybe the field type's like uint256 or uint8 or address, right? A field count, so I could say I have 8 uint256s, so now it's a static array. And then a key, a human readable key, so I can look these things up, or so I can generate an ABI just from reading the metadata on-chain. And you add this function. So at the bottom here, if you can see the schema function, you add this function to your 721. Now you're allowing introspection. Okay, so here's an example schema doing this. Those same 4 fields, IDs 1 through 4, field types, uint8, uint32, string, and here's a key one, a relation field type. It doesn't have to be a primitive in Ethereum. You can write a system that is aware of a relation with another 721, and you can have that be meaningful in a standard, right? And so we have keys on the side. I don't know if I'm blocking it over here, trying not to. Keys on the side where these are the human readable parts, and these could also be used to generate an ABI. And all this gives you discoverability. So if I have a standard with this, I can call a contract, I can read the schema, I can determine that these functions must exist, I can know their return types, and I can interoperate with it without having to know anything about the actual contract code itself. In fact, they don't have to publish the code. It's fine. The schema tells me everything I need to know. So you might be asking yourself, okay, on-chain sounds cool. What about gas usage? I mean, wouldn't this have happened before if it was cheap and easy to do? Well, it turns out that if you just do this naively, if you say, all right, I'm going to write an application and I'm going to put all of my stuff on-chain, that it can get gas heavy. Ethereum mainnet is a problem. It is expensive. But there are actually a number of ways that you can optimize to reduce it. We were doing some game design to do a game that would run off-chain and do rewards on-chain, but then we wanted to rewrite the entire game as Web3 and put it on-chain. And the first thing we ran into was we don't need to have 20 different fields. We don't need to have a struct. And by the way, if you think that Ethereum packs structs efficiently, it does. But has anyone used Compiler Explorer before in the past? There's a tool called Compiler Explorer. It supports Solidity. If you care about efficiency, I recommend dropping your contract into it and see what it does. I believe it's at godbolt.org. But it will tell you some very revealing things that happen that consume a whole lot of gas. But you don't have to do that. You can pack your data in and you can write your own routines that make it so that you consume like one field, like 2 storage slots, and you cut your gas usage down dramatically to get your data online. Also, L2s have done an amazing job mitigating the costs. It's an order of magnitude cheaper to use an L2, and those didn't exist previously. So can we make a full relational database management system on-chain with queries and indexes and all that stuff? Not really. Not exactly the way you're thinking. It is so prohibitive to scan through large amounts of data on-chain. It's so gas prohibitive to do that that's not really the goal. But the main thing is that we can get a lot of utility just having the relations and the core data that we need on-chain, and we can bring atomic transactions into play and have data integrity, have ownership, have inheritance, and stuff like that. We don't need a full RDBMS to do it. So once you're in atomic transactions, and what I mean by that is not reaching out to servers to read metadata, keeping it on chain. You can create relations with data integrity. You can inherit, meaning that if I have an NFT, a 721 that's a sword, and I have another 721 let's call it a red gem, and I want to assign the red gem to the sword to power it up, and it's a one-time use rule in my game, I can have that relation, and now I can make it so the owner of that red gem 721 is the owner of the sword. So that if that user ever transfers that sword, the gem just goes with it. It's still there, the history's there, the relation's there, but that's something very powerful that I can do, and I can guarantee it on-chain with an atomic transaction. Okay? And in fact, you can get down to where entire applications can deploy with only a client where you don't need server-side components at all if you do this. For some applications, obviously it varies. And you can take, if applications do this, you end up being able to bootstrap off of one another, where because someone's using the data, you can start adding some data and gating off of theirs. So existing 721s and 1155s aren't totally out. You don't have to rewrite everything. You can extend them permissionlessly. You can integrate on-chain metadata with what's existing off-chain. In my group, we call it patching. And all the stuff that I'm talking about, I wish I could have added more code, but we've been working on this for about a year, and there's thousands of lines of code to look at. But we do have an implementation, but we've worked on all these features, and there's a whole lot there, and I could talk for quite a while longer about this, but that's pretty much the list. If you're interested in our implementation of this and what we do, or you just want to use it as a reference, got a number of links here, and I'll give you a QR code at the very end if you want the deck and you want all the links as well. And I believe the future of blockchain is more data on-chain, richer data on-chain. I think that you're going to have app interoperability where an app shows up, does something cool, and another app gets an idea based on that one and does something cool up to piggyback it. And I think that you're going to start to have apps with EVM-based backends that consumers are unaware of. And what I mean by that is you can apply the parent test. Is my parent using something that's got a blockchain behind it and they don't even know? Right? I think that's going to happen. This is a QR code. Please, for the deck, please scan it if you want access to the resources or you want to be able to review or contact me or anything like that. And I have 15 seconds left, so I'm going to end there. Thank you.
Hello, everyone. On behalf of my company and myself, we're really excited to be here at ETHDenver, and we'd like to thank the organizers, the stewards, the volunteers, and the staff, everybody who's come together to make this event so great. Let's give it up. Octane Network is a data intelligence company. We do on-chain algorithmic reputation and other analytics. My name is Scott Emig. I'm a principal scientist at Octane. My background is from the web world, web search, paid search, recommender systems, personalization. So you'll see that flavor in this talk, both the data science flavor and the Web 2 flavor, but I promise to bring everything together for something that's very relevant to blockchain. So all right, everyone, let's get into it. This is the Octane business model. Our stack is in the middle. We have a distributed GPU compute protocol and a reputation ranking system. We're a B2B company, so other businesses pay us for services and analytics at different levels of the stack. This talk is about on-chain PageRank, and it's related to a blog post from Brian Armstrong from August 2023, where he gave 10 ideas for startups that he would found today if he was starting a company today. And they're very innovative ideas. Network states, Flatcoin. And among these 10 very innovative ideas is on-chain reputation. And one of the points that is made in that blog post and the video that went with it is that the web has exactly the same data structure as the blockchain. On the web, you have pages and hyperlinks between pages. And on the blockchain, you have addresses and transactions between addresses. So anything that can run on the web graph can run one-to-one on the blockchain without modification. In particular, PageRank can run on the blockchain and provide a reputation score just like it does on the internet. So to give some credibility to this idea, let's look at the sizes of these two graphs. The web in 2024 has 202 million active websites. Ethereum in 2024 has 205 million active addresses. The sizes are not just the same order of magnitude, they're almost the same number. Of course, there are differences. It would be nice to know more about the web topology, but that's a very difficult research problem, things like diameter and connected components. Because in order to know about the web, you have to crawl it. And the crawler is always behind reality because the web is always evolving. Contrast that with the blockchain. At any given time, we can know exactly the state of the blockchain. And not only can we know exactly the state of the blockchain at that point in time, but we can know the historical state of the blockchain at any historical point in time. And there are other important differences. In the blockchain, for example, the transactions, which are playing the roles of hyperlinks, have a lot more information. They have amounts. Higher amounts are more important. They have ages. An old transaction may be less important than a newer transaction. They have multiplicities. Two hyperlinks from the same web page to another web page doesn't carry the same importance as two transactions from the same address to another address. So all this goes together to kind of demonstrate that PageRank is not only applicable to the blockchain, but PageRank is more applicable to the blockchain and more powerful on the blockchain than it is on the Web 2. Let's just review and introduce the PageRank intuitions and maybe one or the other. PageRank is based on a random surfer model. The idea in the internet is that this random surfer, this hypothetical surfer, goes to a random web page. And then on that web page, they randomly select a hyperlink. And they go to the target page. And on the target page, they randomly select a hyperlink and go to the target page of that. And they go on forever. And if they go on forever, then at some level of approximation, the page rank is the the percentage of visits that each page has. There's some additional components to PageRank. One thing is there are dark corners of the internet where the random surfer can get stuck. They can get into that dark corner of the internet, but they can't get out because there's no hyperlink getting out. So in order to account for this, PageRank allows this random surfer to jump with some probability. Usually it's set to 20%. 20% of the time, instead of following a random hyperlink, they will choose a web page at random and then go to that web page. And in the internet world, this is done with a uniform random distribution, usually. So all the pages on the internet are equally likely to be chosen. But it's not necessarily the case that it has to be a uniform distribution. This random surfer may, 20% of the time, jump to the same web page or to the same group of web pages. Or the random surfer may prefer certain web pages over other pages. This is called personalization in PageRank. And so it's possible not only to weight transactions by their amounts and ages and multiplicities, but it's possible to weight addresses by anything that you know about the address, maybe the balance at that address. This leads us to adapted PageRank. Blockchain has these features, and we want to incorporate that information into the algorithm. So we can weight nodes and edges according to everything we know about the blockchain. And this is not the first time it's been done, applying this to blockchain, adapting for blockchain. It's not the first time. For example, in city networks for city planning, some applications want to find the important intersections between city streets. But some intersections may have a big building on them, or some intersections may have a vacant lot, and some may have houses. So the features of the intersections are actually possible to incorporate into PageRank before PageRank even runs. And then let PageRank do what it does. This allows us to tune the PageRank algorithm using all of the information that we've been discussing to be very specific to a scenario, or to be very well tuned to the blockchain. So let's suppose that we adapt PageRank to the blockchain. And we've used all the math and all the intuition, and we've asked all the experts, and we think that this ranking for reputation based on PageRank and all the weightings that we've assigned is a pretty good ranking. How can we tell if it's really good? Well, if there are data scientists here, they'll tell you what you need is an independent truth set where you can take the reputation ranking and you can compare it against this independently generated truth set and see how the reputation ranking performs against the truth set. Fortunately, the blockchain excels in this regard too. For example, the Arbitrum airdrop did not go to every address that met the criteria specified for the airdrop. Certain addresses were eliminated. Some of them were eliminated because they were large, publicly known addresses and they weren't qualified for the airdrop. But some were eliminated because they were bad actors. They were spamming the network, and so they were disqualified from the airdrop. So using the Arbitrum airdrop, we can say that anyone who received the airdrop is true quality, high reputation. Anyone who didn't receive the airdrop is low quality, low reputation, and false. Or we could look at EtherScan. EtherScan actually has warnings for certain addresses. Such and such authority has warned that this address may be associated with a Ponzi scheme. So we could say that anything that has an EtherScan warning is potentially low reputation. We should treat it as false reputation. Anything else we can treat as true reputation. We don't really care where anything else falls in the ranking. We just want to eliminate any of these EtherScan addresses with warnings. Or the other way around. Maybe there's a large trusted entity. Let's say Uniswap. Uniswap has many addresses. And so we may think that a lot of people trust Uniswap, and let's say that we want to give high reputation to the Uniswap addresses. So we could give a true value to that. We could say that's high reputation, that's true reputation. And everything else can be false. It doesn't matter where anything else falls. We just want to be sure that the Uniswap addresses appear near the top. So let's look a little bit closer at the Arbitrum airdrop. How did Arbitrum detect the Sybils anyway? They used a clustering algorithm on the transaction graph. Clustering algorithms on large graphs can be very expensive. And so we can take the output of that very expensive operation and the existing reputation score and see how those two compare. And we can actually measure this and assign numbers to it and use the number to improve it. So the way that we can do that is rank all the addresses by their reputation score in descending order. The very highest reputation is at the top of the list. The very lowest reputation is at the bottom of the list. Everybody else is in order in between. And then suppose you were going to launch another airdrop on Arbitrum. You might want to use the relevance score, the reputation score, to determine which ones would receive the airdrop. So we can set a threshold where you think that above the line, those are pretty high reputation, and those should get the airdrop. Anything that's above the line and got the Arbitrum airdrop, we treat as a true positive. It's high reputation according to the reputation score, and it's high reputation according to the Arbitrum airdrop. Anything above the line that did not get the airdrop is a false positive. It's ranked highly according to the reputation score, but it did not get the airdrop, so it's a false positive. And the true positive rate is the percentage of the true positives, and the false positive rate is the percentage of the false positives. You can see that for different business scenarios, it could be very useful to adjust that threshold. Let's say that for your new airdrop, you wanted to be sure that everybody who possibly qualified for the airdrop would get it. And we don't really mind if a few bad actors also get it. Then you could set the threshold very low. You could capture almost everybody who's a good actor, and you also get a few bad actors, and for certain scenarios, that might be okay. Or the other way around, let's say that we really want to eliminate any Sybil attackers. We could set the threshold very high, and then a lot of people who were good actors would not get the airdrop, but we would at least not be getting a lot of bad actors with the airdrop. So the threshold can be adjusted for different business scenarios. And between any of these two addresses and this long vertical list of millions of addresses, there's actually a threshold. And that threshold has a false positive rate and a true positive rate. So being a data scientist, I love charts and graphs. And we can chart this, the true positive rate on the y-axis, and the false positive rate on the x-axis. And this is known in data science as the receiver operating characteristic curve. You may have heard of it. Any data scientist will tell you this can be very useful for measuring the performance of a ranking. And the way that you use it to measure the performance of the ranking is that the percentage of the rectangle that's underneath the line is your score. So on the left, we have a lower quality ranking, and on the right, we have a higher quality ranking. There's 61% of the area is under on the left, and 84% is on the right. 84% is a very good number. This is real data against the Arbitrum airdrop using Arbitrum reputation scores computed from before the airdrop. And if we were a pharmaceutical company and we got an 84% area under the curve, we would take that product to the next step. And if we were a web search company and we got an 84% area under the curve, we would take that model to the next step. So 84% is a positive result. It has a signal. And we can not only do that, we can not only do one experiment. This is just one experiment. We can do any number of experiments because we have transactions with amounts and ages, and we can adjust how we're weighting those transactions according to their amounts and ages. And we can also adjust how we're weighting nodes and improve on this score over and over and get that area under the curve higher and higher and higher. In the case that I'm showing from the previous chart, from the previous slide, we were actually experimenting with weighting nodes according to either incoming or outgoing transactions. And it turned out that one was much better. The other one had a signal, but this was much better. So there are a lot of opportunities to adjust this. So for future work for the reputation scoring algorithm, we are comparing these scores against other truth sets, other airdrops, and some of the other truth sets that I mentioned. There are also a lot of tools from the web that we can apply that are related to area under the curve, but other tools like precision at in. There are other analytics that are important. Maybe this high reputation address got the airdrop, but did they just sell the Arbitrum tokens when they got the airdrop and then stop using Arbitrum? Or are they still users of the Arbitrum? And can that reputation score predict that? We're moving toward decentralized compute for algorithms and visualization. This is a DPIN initiative. And we're moving toward decentralized Oracle for reputation. So this is my final slide. And I have an email address on here for inquiries. We're very interested in connecting with you. We're interested in connecting with partners. We're interested in connecting with customers. We're interested in connecting with investors. And we're interested in connecting with other engineers and data scientists who are interested in algorithmic reputation. I also have a POAP up here. And the POAP is on a piece of paper. And the piece of paper is my business card. And it has all my contact information along with this email address. So if you see me after the talk or you see me anytime during the conference, please say hi and I'll give you a POAP. So thank you for everybody's attention and have a very prosperous and good and productive week this week and at ETHDenver. And I really appreciate your attention. LFG.
Hi, everybody. Just announcement from stage. We have our next event on stage at 2:30. So if there's anything you need to do, we'll see you then. Thank you.
Just hanging out.
Yeah, that's fun. It's better to feel
I'm
comfortable.
hoping seeing somebody on the stage will kind of draw some people back in a little
Yeah,
bit.
totally.
Yeah, because we had a lot more people before the break, unfortunately.
Yesterday was kind of the same way. Like
Okay.
after lunch, it kind of like emptied out a little bit.
That's okay. It is what it is.
It's still early days. Next week's gonna be popping, I think.
Yeah. Yeah. Do you expect to fill this whole venue? That'd be a little crazy.
I bet it'll be pretty busy next week.
Yeah.
Because the other side of the building hasn't even happened yet. You know?
Yeah. Yeah. It isn't even open yet.
Yeah, totally. We gotta set it up on Monday. So.
Oh, man. That's gonna be a lot of work.
Yeah, yeah.
Okay. Well, that I think I can do. Yeah. Yeah. Sound working good? Excellent. Excellent. Okay. Well. Hey everyone, I'm Justin. And do you have the display? There we go. Okay, really right up here? Okay, cool. Okay. Good afternoon, everybody. I'm Justin, co-founder of Althea. And today I have a talk that's about Althea L1, but really the design decisions behind it. So for that, we're going to need to start with some context. So Althea is a DePIN project, decentralized physical infrastructure. Although we really predate that definition by several years, and I'm not really here to talk about Althea the application so much as the L1 that we have built to support it. And this is because I think it's a really interesting alternative interpretation of the scaling problems that sort of dominate blockchain design discussions. And what I found really interesting as we went through this process of designing an L1 for Althea is that the choices that we made and the options that we selected were completely different from the normal, more DeFi-focused blockchain design discussions and decisions. So this led me to want to sort of present all of these differences and really talk about what does DePIN need in a scaling platform as a sort of contrarian, or I guess not really contrarian, but an alternative to the sort of L2s, L3s, ZK discussions around DeFi scaling. Now, I should get out of the way some context. So Althea is a protocol that allows devices to buy and sell bandwidth from each other. So for the super short elevator pitch on that, just imagine that your cell phone could buy bandwidth from any cell tower, not just one of the three main providers, but any cell tower, anyone set up, as a metaphorical equivalent of just kind of handing them a quarter as you walk by in order to buy some data. And so, yeah, this is a microtransactions application. It's really about creating a market for bandwidth. And we have been working on this for 6 or 7 years now, depending on how you count. And we are selling, we are an ISP to thousands of homes in 15 states and several countries. And we have real customers buying bandwidth using this system from for example, a fire station, to just regular people who are not familiar with crypto at all using this as an application. So now we're starting to think of, well, not starting, now we're implementing, what does it take to do this at scale, to have a bandwidth market like this running for everyone in America or everyone in the world? And how do we make sure that it scales and everything works out? So without further ado, let's get started and sort of jump right into the technical decisions. So first of all, how much block space do you really need anyways? And I think this is one of the things that is this is one of the discussions that's sort of dominated by more block space better arguments. And that may be reasonably true in the case of DeFi and sort of financial applications. More block space creates induced demand. So the lower your gas costs, the more transactions you're going to get to arbitrage all the pools and to arbitrage between different protocols. And it just goes on forever, really. But that's not true when you are buying and selling what is, I like to think of bandwidth as a physical good because it's transmitted through the air. It's really not so different than a candy bar. Once you have downloaded some data, the sender cannot take it back, and they still want to get paid for it. And the interesting thing about microtransactions applications in this sort of context is that you think, well, okay, you want to send transactions as often as possible, right? That's not really the case. In fact, the frequency with which you want to send transactions is bounded by the latency of the system that is accepting the transactions, so finality speed. And that's an unintuitive answer until you start thinking about trying to write the code that actually does this stuff and start trying to think about writing it in a way that is reliable enough that your phone is not constantly ringing. And to do that, you really need to worry about what transactions are in flight. What is final, what is not final, what could be reverted, what could be changed, what if somebody unplugs the device, what if somebody reboots the device, what if somebody reboots the receiving device, what if the receiving device has corrupt memory because it doesn't have ECC. All of these things are things you really need to worry about. So being sure that you have sent your payment, that it has been finalized on the blockchain, and that the receiving node understands that it has been paid are really your constraining factors. So what this means is that you don't want to settle every, 1 second, 5 seconds. You really want to settle every couple of cents, maybe 1 cent, 5 cent, anything more than that, and your tracking logic starts to go wonky. Because so let's say you have a centralized shared sequencer that gives you an inclusion proof. This is the fastest you can possibly know that your transaction has been accepted. How fast is it? How fast is it really in the worst case? And the answer to that is probably about 1 to 2 seconds. So that's not actually that much better than the finality time you can get so we ended up selecting Tendermint consensus on a Cosmos base, and finality times sit around, somewhere between 4 and 8 seconds. So as a single centralized sequencer acts as a single point of failure in the sense that, well, point of failure, point of liveness failure, I should say. There's safety failures as well. But you're not getting a big benefit from it. You can have a decentralized validator set, and ultimately, your biggest constraint about how many transactions you want to send doesn't change. This is a really interesting and unintuitive conclusion, and it's kind of the sort of thing that this whole talk is about, is what we've learned building Althea and running a DPIN application, and how that influences what you actually want to build. So anyways, the ultimate conclusion for this is that you don't really need an enormous amount of block space. In terms of block space, everybody's going to be settling, let's say everybody was streaming 4K video continuously, they were all paying some absurd price per bit, just to generate more transactions. You're talking about maybe tens of thousands, tens of thousands per minute, to a couple thousand per second to settle all the bandwidth in the United States. And that's if everybody was watching 4K Super Bowl same time, et cetera, et cetera. So you don't need to start to get into really crazy scaling solutions or ZK proofs or lots of multiple shards. You can reasonably do this with a simple validator set and well-optimized code. Even more interesting than that, and on the same subject, is that scaling for DeFi is actually a much harder problem, which you may have already guessed listening to just the first couple of minutes of this presentation. When you're doing transactions for real-world value, you can parallelize them really easily. You're not talking about reducing the composability of a programming environment like the EVM that is fundamentally about, so the value of the EVM is fundamentally about composability. That composability fundamentally requires that you serially execute each transaction, and means that means that you can't really take advantage of parallel processing on an individual validator very easily. Whereas if you're processing a bunch of just straight up hard-coded A sends money to B transactions, these can all settle at the end of the block and be processed in parallel, and then you wrap up the block and do the signing in one thread at the end. So this means that for Althea L1, we've gone with a hybrid platform where we have both a base layer that allows us to send just bandwidth transactions as a special type that we can process vastly more efficiently, and then EVM, and then an integrated EVM that is useful for DeFi applications that want to be close to the actual bandwidth sales, but at a really high price, because we're not really optimizing. Well, really high price is relative, but we're not really optimizing for enormous EVM throughput. We're optimizing for enormous bandwidth transaction throughput. And once again, I think that this is interesting from the perspective of how much what you were trying to do constrains your scaling concerns. And this brings us to the last point, that while figuring out a form of parallelism and increasing the speed of serialized execution is the hardest problem for EVM chains, the hardest problem for a chain that hopes to be a settlement layer for real-world exchange, whether that be candy bars, bandwidth, pretty much anything physical that has to change hands, you need two things more than anything else. You need some form of instant finality to get more, to actually get the transaction throughput there and to simplify your applications. And you also need a way to handle the RPC problem, which is actually really, really hard. Because when you are dealing with DeFi, it's relatively reasonable to have a very high full node, or I should put it this way, RPC node to user ratio, because users are not transacting all the time and do not need to be observing the blockchain state constantly. There are arbitrage bots and such, but they can pay for their own infrastructure. You don't have a router that needs to know when it's been paid, a point of sale terminal that needs to be always on and watching for payments. You don't have essentially an enormous query load that is the real bottleneck when dealing with real-time payments, because they have to remain real-time. So obviously, no matter how many queries you run, the validators are going to keep producing blocks at about the same rate. You're not going to knock them down. But if the users cannot query and know that their transactions are finalized, we're back to the first point. We don't have fast enough finality. So this is why I think the light client space is really underappreciated, and that the current concepts behind client diversity in Ethereum and in other blockchains are insufficiently advanced. Why do we have only one type of client that's a full client and an archive node, and it does only those two things? Because we really need more effective light clients that start to eliminate these RPC problems, start to run in a web browser, and give us query capability that is really efficient and useful. Now, unfortunately, Ethereum has designed itself into a corner here with its own, with its non-final, sorry, I'll put it this way. The delayed finality in ETH2 consensus fundamentally makes it extremely difficult to make a lightweight light client like this, because the proofs that are needed to do that don't really exist in a practical way. This is useful for Ethereum because it provides additional resiliency in that it's not final, but because there is no finality, you have a data availability problem, and the data availability problem cannot be solved with a quick proof. So that is a bundle of words in there. But long story short, for our application, for DePIN applications, we need to be able to bootstrap a light client that can effectively query other nodes for blocks in a, couple hundred megabytes of RAM at most. So the, okay, sorry, I'm not going to go on a detour about home Wi-Fi router hardware and how much RAM they have, but that's an entirely different lecture, and is something that has been a really fun problem, interesting to work with. But anyways, compared to a home Wi-Fi router, a Chrome tab is practically roomy in terms of resources. So Yeah, so particularly we chose Tendermint as our base. Tendermint provides sacrifices, liveness for instant finality, which we needed before, and we also need now to make effective light clients. And these effective light clients are critically important to maintain the query load when you have, let's say, 300 million households, 2-3 devices each. All of them are looking at the chain pretty much continuously. That's not practical to do any other way. You need an efficient light client, or everybody's going to be having the same terrible experience that blockchain natives have when you're trying to use a chain and the RPCs are heavily overloaded or not responding, or when you have to pay out the nose to Infra to get yourself something stable and sort of avoid that problem. Now, this brings us to the last one, and that is that data availability. I think this problem is sort of interesting, mainly because the way that it's being approached right now is as a financialization problem. And I don't really think it's a financialization problem at all. And in order to, that's because I'm coming at it from a hardware first perspective. And as somebody who spends a lot of time dealing with physical hardware, that's kind of where my mind is. But in terms of storage, the storage is dirt cheap. You can buy enough storage for a ETH full node, considered to be like a really heavy blockchain, for $64. And the immediate response from anybody who has ever tried to run an Ethereum full node will tell me that that storage isn't fast enough. And that's a problem with the program, not a problem with the fundamental requirements of what you need to do. So, the amount of data you need to store is the same. The fact that you need really fast storage is an artifact of, once again, the expectation that there's only one type of chain client, a combined archive full node. And I think that needs to change with more intelligent light clients. And Ethereum is, like I said, it has some problems with that. You're not going to fit an ETH2 light client in a browser, but you can definitely fit an ETH2 light client in a lot smaller footprint than you have right now if you came at it from that sort of low processing envelope perspective. But right now, the focus on client diversity is just having diverse clients that all do the same thing and not a ultra lightweight client that is prepared to store only part of the blockchain at a time. So anyways, for our purposes, for Althea L1 purposes, if we're talking about many millions of home Wi-Fi routers, point of sale terminals, people's phones interacting as sort of medium weight light clients, where you have a few hundred megabytes of RAM and maybe a gig or two of storage, data availability becomes a logistics problem. You just have to have each node store a random distributed sampling of all the blocks and respond to queries for them. And if you have a sufficient number of nodes, then data availability ceases to be a problem. The issue, of course, is having a sufficient number of nodes, which ties back to why we need lighter clients, so that running nodes is far cheaper and there are far more of them. It would also help if they didn't require such enormous amounts of maintenance, but that's part of the design requirements of building a lighter weight client. Okay, so hopefully I have not just all confused you all silly, and there are some intelligent questions to be had. Well, either way, there is, we have some merch over at table A5. Yeah, that includes free t-shirts, although I don't think for long. Yeah, I'll be happy to answer questions and talk about this after, since it looks like I'm going to run out of time in a minute anyways. Thank you, everybody.
translation. It's however you want to do it.
Yeah, I'll probably just do it then.
Let's confirm with our video person real quick if we're getting audio and video. Also, I'll start with video, so you just leave that.
Okay.
Can you get sound real quick? Oh, yeah, so we can leave that in. Let's go for your devices and send audio from HD. Yeah, or how about sound? You just have to set your input block your device. Yeah, so let me just do this. And then let's hit that again. Cool, we got it. Awesome.
Alright. Awesome.
We have it.
So, yeah, I'll look at this.
Like an external display. Yeah, that should be fine. I mean, we can just set up your display settings here. Yeah. And then, oh yeah. So you can say stop here, and then maybe what we
yeah, I mean, it's just going through slides.
or like kind of at that point. Like so anywhere near screen.
I'll probably
Yeah, we just want you kind of forward a bit more so that the camera doesn't see the screen.
yeah, I'll be reading over it, so it's very much like my background inside.
Sweet. Cool. Well, we will
A minute, and this is already
it might be muted out front right now.
awesome. Cool. Thanks, man. Cool.
Okay, welcome everybody. Thank you for coming. I'm Colton. So 1 year ago, I came to ETHDenver with an art project that I called the Infinite Garden. So this was 20 collectible cards, it was physical cards. Every card represented something in crypto that we all know and love. After ETHDenver, I returned to living in my parents' basement. It was the bear market after all. And over the following 12 months, my brother and I created an entire trading card game. We sold out at DevConnect in Istanbul, and we're now partnering with the University of Ethereum to create a digital version of the game. It'll look something like this. So some of you may see this screenshot and go, okay, I've seen games that look kind of like this. What sets Ace apart? A couple of things. The first one is I think we have some really special game mechanics that make it a lot of fun to play. And you'll be able to play it next week. We'll have a booth. You can come by, check it out. Also be talking about it a little bit later. The second part is that the cards are crafted by the community, so people like you. And the third is the story. So a great narrative makes an experience really, really engaging. And Ace has one of my favorite kinds of stories because it's not just fiction. Every card represents real-world innovations and the heroes and villains behind them. So we have this ever-evolving, expanding universe of your favorite crypto themes and memes, and the cards are meaningful because they represent this real adventure that we're all living. So I think of this as metaverse mythology. And I'm going to be sharing this mythology with you by taking a couple of the cards from the game and showing how they track to my personal trip down sort of the rabbit hole. But while this is a personal story, I think many of you will find it quite relatable because we share many of these chapters. So this is the crypto hero's journey. Chapter 1, the ordinary world. Actually, I have some music for this. Let me see if I can get this playing too. Yeah, we're not gonna worry about that. Okay, so the ordinary world. Anon had the dream position as a character artist on the Spider-Man video games. Okay, this part might not be quite as relatable, but hear me out. He worked alongside world-class game developers and artists on the hottest PlayStation 5 games. It was then Anon learned the saga of Beeple, an artist making extraordinary amounts of money using a strange new technology called NFTs. He immediately understood the significance of this technology for artists. Digital art had gone from worthless to priceless. How could one refuse such a call? He cast aside the security of his job and leapt down the mysterious rabbit hole. Chapter 2, Challenges and Temptations. In the beginning, his aspirations were noble. Anon wanted to be an independent artist, to wield his work as a beacon of change. Yet the siren call of the bull market whispered sweet temptations. The fervor for NFTs reached all-time highs, with meme coins minting new millionaires overnight. The promise of prosperity was irresistible. The mantra was simple: get the alpha, board the rocket, and ascend to the moon. Ensnared by visions of laser ray to 100K, he dreamt of his inevitable Lamborghini, for he was no mere mortal. He was a Giga Chad, armored in conviction, wielding the simple strategy of buy low and sell high. In the mirror of his mind, he was an invincible crypto bro. Yet beneath this facade, he was but a greedy little coin collector, clutching feverishly at every coin within his grasp. He dabbled in DeFi, chasing the elusive next airdrop, amassing a horde of altcoins, each promising to be the bane of Ethereum. He tried trading, but his ventures were fraught with peril and disappointment. He turned his hand to yield farming, only to find his efforts barren. He wanted to rage quit. Where were the fabled riches? Where was his golden ticket? When Lambo? In the crucible of his trials, he had to change strategies. He stashed away his coins and prepared himself for the next chapter of his journey. He had learned that in the crypto realm, it's best to choose participation over speculation. Chapter 3, Allies and Enemies. With Bankless as his guide and an orange metafox by his side, he traveled west into new lands. His first adventure took him to the grand do-your-own-research library. There he learned to not trust everything he heard, and instead seek truth from legitimate parties. Wandering the hallowed library halls, he learned of Satoshi's spirit, why Bitcoin was created, and the ethos behind crypto and the cypherpunks. He learned of the fiat fountain, the mystical source of sky-high inflation. Around yet another corner, the ancient game of the prisoner's dilemma unfolded before him. He witnessed the ruthless vampire tax, where emerging platforms drained liquidity from established ones. He uncovered account abstraction, a breakthrough that made crypto more accessible to everyday users. He delved into the world of zero-knowledge proofs that enhanced privacy and security for transactions. He explored Layer 2 ecosystems and the MEV bots that exploit the ordering of transactions. He learned about the threat of Sybil attacks, where a single entity creates multiple fake identities to subvert a network. He learned about the DAO Reaper, an evil monster that had crushed the DAO, and the Lazarus Group, a guild of hackers that stole millions from unsuspecting souls. Understanding these monsters allowed him to successfully dodge rug pulls and the Discord DM demons. The infinite garden of Ethereum was as dangerous as it was promising, and he was a mere anon, wandering the land, seeking to level up his skills. His journey beckoned him onward towards the quadratic lands. Chapter 4, The Innermost Cave. When he arrived in the quadratic lands, he met a warlock they called Owaki. Owaki offered a choice. Take the green pill and see the bright future they could build, or take the gray pill and return to the degenerate zero-sum games Anon had been playing. Anon took the green pill. The regen vision flashed before his eyes. The tragedy unfolded before him. He saw Moloch, the demon of coordination failure, described in the Slate Star Codex. Moloch tore at the very fabric of our good intentions, ensnaring us in a web of competition and self-destruction. Another flash, an alternative reality appeared. Win-wins enabled by Web3. They had the decentralized technology to coordinate humanity and maybe just slay Moloch. His next mission was clear. He joined a guild working on NFT fundraisers. They launched an NFT campaign that raised $500,000 for Gitcoin grants. They were directly funding public goods like open source software and Web3 education. As his journey continued, he met more regens, worked alongside characters, and uncovered Ether's Phoenix and its paradigm-shifting retroactive public goods funding abilities. The summer was hot. Everything was up and to the right. They should have known the winter was coming. Chapter 5, The Ordeal. A manifestation of Moloch had been gaining power. With his legion of zealous followers, it seemed the Luna Empire was unstoppable. Yet overnight, the fragile edifice shattered in spectacular fashion. The token's downfall erased fortunes in the blink of an eye. The devastation rippled far beyond, unleashing a contagion that ravaged the crypto lands. Countless souls were swept away in the merciless tide of liquidations. Just as the remnants of the storm seemed to settle, A final extraordinary blow-up sunk untold fortunes into the abyss. Chapter 6, The Road Back. As the dust settled, lawmakers cast their gaze upon the fractured crypto realm. Politicians spoke loud with their eyes wide shut. Sanctions crushed innovations. Protocols were outlawed. The whale population decreased significantly. Many retail investors got paper hands and left with their losses. Together with survivors of past cycles, they watched the bear market sweep across the land. Chapter 7, The Reward. The winter was upon them, but this was just the beginning of their journey. Anon had made a steady income through grants and art projects, and met incredible friends through new Web3 communities, like Zuzaloo. We live between two worlds, the ordinary world and the special world of crypto. ACE is our vision of bridging those worlds through a fun experience about the crypto hero's journey. We believe Web3 is magic, and by learning to wield this magic, we can shape a better global society. The cards I just showed represent my crypto journey, but like I said, many of us have shared this path, and there are many adventures to come. ACE is one journey that I hope we embark on together. As of now, ACE actually has two games. A finite game where players compete, and an infinite game where players create cards and balance mechanics. Let's begin with the finite game. And by the way, you can swing by our booth next weekend. You can check it out. So for the gameplay, flash gems spark awesome comebacks. Ace cards lead to epic final action sequences. Shields are an intuitive way to protect against unfun matches while opening the door to cool new mechanics. And we keep the basic rules simple so you can just jump right in. But don't let that fool you, because there are a whole world of sneaky mechanics and strategies that you can master. So whether you're planning your next big move or pulling off an epic comeback, Ace is all about those unforgettable moments that'll have you wanting to play again. All right, so we've got a really fun competitive game. Now let's switch gears, talk about the infinite game. The way games are made is changing. 2 people made Ace. And with new game design tools and this extraordinary wave of AI, we don't have to build a large team to make a digital version. That means we can do things differently. Unlike those big traditional franchises that keep rehashing the same stories and games, Ace breaks free of top-down narratives with designs and mechanics dreamed up by you. It's like we're all sitting around a giant table, throwing in our best ideas for new cards, tweaking the rules, and evolving the game to be more dynamic and exciting than ever. Some of the most popular cards in the Alpha Edition were crafted by the community, and this is just the beginning. Collective creativity also fosters a deep sense of ownership and connection. When you create a card, you're leaving your mark on Ace's ever-expanding universe. And it doesn't stop at creating card designs. One thing I'm really excited about is that by using generative AI, anyone can easily craft skins for their favorite cards. Skins can make designs more personal, they can take the story of a card in a new direction, or just create a flavorful way to celebrate an upcoming holiday. You can also create new playing fields that capture the vibrant diversity of the crypto landscape. Each of these contributions can be rewarded through tokenomics or through NFTs, because remember, with NFTs, everything you create or collect in the game is yours to keep, trade, or expand upon. Each card is a little piece of the Ace universe. And who knows, the card you design could be the next big hit, or even spark a whole new game or story within the Ace world. So we've talked about narratives and art, and when it comes to balancing, many games crumble when their centralized teams make unilateral decisions that don't align with their community's desires. Ace takes a different approach. Found a card that's too OP, or maybe you've got an idea for a card that could shake things up? Jump in, let's make sure every change is embraced and celebrated by those who play Ace the most. So in closing, we have a game that's really fun to play and an ever-evolving adventure that you can be a part of. I invite you to join us on this epic journey. Create a card, tell your story, and shape the world of Ace. Together, let's discover just how incredible a game can be when it's limited only by our collective imagination. Now, I've got one more piece to share with you, which is that until now, we've been making these community cards by just holding small events. We'll do little creativity exercises. People will vote on different cards that they like. But I have been like the sole bottleneck for this. And in the spirit of building, we've just launched the very first version of the web app. So you can now just start creating cards. So this is very early, first version. You can only create creatures right now. It's only one color. But huge shout out to JMill for making this. It is an amazing, amazing piece that he put together. It's all powered by Eden. And you can scan this QR code to join the Discord. And in there, you'll have a link to go straight to the card creator. Again, the most fun part of this project for me has been just working with other people to come up with these cards that represent this shared journey. And I would love to see the cards you come up with. You can just share them back in the Discord. And I hope you have a really good time with it. We've been having a lot of fun with it already. So I can try to take questions. The HVAC is quite loud, so you'll have to really shout. Does anybody have any questions? Any hands? So I'm just going to be parked over here for a little while, and if people want to chat, I'll have some cards with me too, so you can check those out. Thank you so much.
Depending on how you've got it set, some people have been doing like the extension, where you've got everything in here. Yeah, so like how, however you have to set up whatever works best for you. If you want, you can check out Clicker if you want to use that. forward on the stages that you take. So you can be anywhere here as long as you have a if you really do just want to what we're trying to do you know what I mean? Like it just works best. Oh yeah, that's okay. People have been doing that all day. Yeah, it's okay. Cool. We'll start when that timer hits 0, so we have on the sport next. Cool. Thank you. That microphone is on, so it's ready for you. We'll start.
All right, guys. Hi, good afternoon. My name is Darren Camus, and I'm here to talk to you about how we built the derivative for that sweet ultrasound money yield. So this will be quite deep into DeFi. The interest rate derivative market in traditional finance is 450 trillion. It's one of the largest derivatives in all, it actually is the largest derivative in all of finance, but we don't know much about it inside of DeFi. So if you look at something like the perps market, which has a market cap of about 50 billion, the interest rate derivative market in traditional finance is 9,000 times larger. So that's a little context about derivatives around interest rates in general. So IPOR at its core is a protocol that's about three things. It's about data, it's about derivatives, and both of these enable structured products. So before I get into how you can secure this sweet money, sweet ultrasound money yield, I have to build the case of how this all plays together. So the IPOR index, we consider it like a LIBOR or SOFR-like benchmark for DeFi. All it means is what's the cost of capital in DeFi today? And as extension of that, you can think of the staking rate inside of Ethereum as the risk-free rate in DeFi. So these kind of have two parallels on the data side. And then if we look at the interest rate swap, or what we'll talk about a little bit later is the stake rate swap, it's a traditional derivative instrument. You use it for hedging, you use it for speculation, and you use it for arbitrage. Okay, what's important is the IPOR index and also the stake rate indexes. These are public goods. So how it happens in traditional finance is if you're building a credit product, your bank is going to quote you a rate. That rate's coming from one of these indexes. They're going to say, okay, you want a home loan? I'll give you the SOFR rate plus 50 basis points or 0.5%, right? And so this contract that's written on pen and paper dictates what you'll pay for your mortgage over time. So in the same way, we can build this in DeFi, where we have this transparent, immutable index that's printed on chain, and actually other builders can point to it to actually structure their different credit, derivatives, and deal terms. And so the IPOR index itself is a public good that's available for all builders inside of the credit markets. So we took this behemoth instrument that is a massive TradFi player. It basically underpins the entire debt markets. And we said, okay, so how can we apply this to DeFi? How can we take something that's typically an OTC swap between two financial institutions, and how can we implement it in decentralized finance? So we adopted this peer-to-pool model, because when you're bootstrapping a market that doesn't exist, you need this kind of nice bootstrapping mechanism. So we built the first peer-to-pool swap for the stablecoin pairs, right? So there's an IPOR index for USDC, USDT, and DAI. Because when we started this project, no one was borrowing ETH. But a little alpha that's going to be dropping later, ETH is one of the most borrowed instruments. Why? Because you can have these nice leverage looping. You can get different trades that are basis trades between the cost of capital, the cost of ETH in borrowing on the money markets, the stake rate return, and very soon, the liquid restaking rewards. Okay, so this chart right here is a chart that's talking about interest rate volatility. So if you guys remember last year, around this time, you had the collapse of Silicon Valley Bank. With the collapse of Silicon Valley Bank, you had people cutting risk in USDC, which caused the USDC rates to plummet. And you had a really nice rate inversion right here. So you had a lot of people that were interestingly playing this basis trade inside of DeFi. So derivatives are very good at either speculating on these volatile moves or actually protecting from them. So if you're paying attention to what's going on and all the talk about the restaking narrative, there's a chance that there's going to be a very strong premium on the staking rate. But there's also going to be a lot more risk. There's going to be slashing risk. There's other validation risk. And that means that you're going to have a lot of volatility. This volatility can be traded. It can be baked into instruments. The derivatives can be used for protection. Okay, so if we look at this kind of structured products, right? If we look at the DeFi stack as a software stack, on the bottom you always have the index. On the bottom you always have the data. So that's the what's the cost of capital for borrowing stablecoins? What's the Ethereum staking rate? What's the liquid restaking rates? You guys are familiar probably most with this kind of markets layer. That would be the Aves, the compounds, the MakerDAOs of this world. On the derivative side, you have something like the IPOR derivatives. You may have the Pindle YT markets. And then how you turn this into a structured product is actually you go through all of these 3 layers to create a nice product up at the top. Okay, so with the IPOR index, we were looking at the stable coins, right? But we're here to talk about, securing that sweet ultrasound money yield. So if you look at this, this is the chart of the Lido staking rate, right? So there's some volatility in there. Obviously, the more people that are staking, the lower the yield goes. If we're in a bull market, we have a couple of NFT minting cycles. Maybe you'll get a spike on the execution layer rewards. So this is a tradable commodity. But Lido prints it once a day on chain. So if you see this chart, the IPOR engineers were one of the first ones who were able to actually get this at the epoch level. So every 6.5 minutes, we have the Lido rate that can be now not only a tradable commodity on a long term, but you can actually day trade the Lido staked ETH rate. So how do we do this? Well, we iterate over the list of the thousands of validators, pay attention to the MEV rewards, pay attention to the different block rewards, and you can see here on this chart, you can see the white dots are the Lido prints, and the blue line is the intraday print, right? So if you have something this volatile, actually on a stake rate swap, you can offer some pretty high leverage, and it's actually not that degen. So on the IPOR swaps, the stake rate swaps on mainnet right now, you can take up to 500x leverage, and on the Arbitrum swaps, you can take up to 300x leverage. The whole idea of leverage inside of interest rate derivatives, it's a payoff over time. It's not like a perp. So if a perp moves, if you have 100x leverage on a perp, it moves 1%, you can get liquidated, right? On a stake rate swap, it's actually an exchange of payoffs over time. So that means, let's say you're an institutional player, right? Everyone's talking about the Ethereum ETF. And we see a lot of these filings get updated where a portion of these funds are going to be allowed to be staked. So the staking portion is where the institutions are going to want to hedge their downside risk on the Ethereum staking rate. And this is where the stake rate swap comes in to these kind of nice structured products. Okay, so how do we bring these to market? Again, IPOR protocol is about data, it's about derivatives, and it's about structured products. So you have to build this nice pipeline. So what does it start with data? So if you look at the data side, you have the stake rate data from the Lido staked ETH rate. You put it through the model, you have this nice feedback loop, and then you launch the market. So this actually, this product pipeline will allow us to launch other derivatives around other liquid staking tokens. And eventually, I think one of the ones that you guys might be most interested in are the liquid restaking rates. Okay, so if we look at 2024, maybe we're out of a bear market. And there's a lot of things that are converging right now. Okay, so if we look at the macro, we have TradFi rates. Everyone was going crazy about RWAs. Everyone wanted treasuries last year. But now we're pricing in rate cuts maybe mid this year. So treasuries are going to be a lot less sexy. But we already have an inversion in DeFi where the stable coins, they have a much higher rate of return, between 8 and 10%. So that means we may have a lot of capital flowing into DeFi in stable coins, in dollars, from traditional finance, from traditional fund structures inside of DeFi. If that happens, maybe we get a lot more speculation on the assets inside of DeFi. Maybe you get a lot more gas fees that are paid. Maybe that puts the execution layer rewards up. Maybe you want to go leverage long on the stake rates. So these are all kind of interesting dynamics that are coming in. So this is like this wave of capital that can come on from traditional finance and actually enter inside of DeFi. The other major play from last year was the Ethereum borrow to the stake rate leverage looping, right? We had entire funds that were structured on this. Borrow, get access to Ethereum staking, rinse, repeat. But we already have people that are talking about this liquid restaking returning 10 to 15%, right? This is going to change the dynamics of the cost of borrowing Ethereum. if it changes the cost of borrowing Ethereum, it could actually change the entire interplay between how many people want to stake. Why would you stake for a 3% yield when you can actually get either liquid ETH at what could be up to 8-10%, or the restaking reward at 10 to 15. So this is going to change this dynamic. So I think we're going to see a huge shift between this leverage looping between the Ethereum borrowing and the staking rate, and there will be a nice tri-party balance between the staking rate, the Ethereum borrow rate, and the restaking rate. Okay, you guys may know this guy. This is what a podcast from a little earlier this year. I want to see how the degens are going to speculate on interest rates. I think everyone is trying to find that native expression of an interest rate swap. And that's actually what we've been building here for the past 2.5 years. So we launched the stake rate swap back in the second week of December. Since then, it's underwriting, I think right now, around 80 million in open interest. And over the lifetime, it's underwritten over around 4.3 billion worth of notional swap volume. So this is important to see. Actually, you have the stablecoin swaps down here, but people really care about protecting that sweet ETH yield. And I think that this is going to be a major driver for the IPO protocol. It's going to be a major driver for the next narratives, and especially for these nice structured products. Okay, so again, we're going to have this kind of tri-party trade. So the trade of the future is going to be, what is going to be the risk on not just the eigenlayer points, but the different validator sets across restaking? What's going to be the rate of return? How are you going to hedge your downside risk in case of a massive slashing event? So for example, in the stake ETH stake rate swap, you can think of a receive fixed position, or basically shorting the rate, as protection against slashing, right? So will we see these actual interest rate derivatives, these stake rate derivatives, will the restaking derivatives, will they emerge as some kind of insurance? Will they emerge as some kind of fixed rate protocol? I mean, this is something that is yet to be seen, but I think this is the nice interplay that we're looking for in, I think, the next 6-9 months when these will go liquid. Okay, so in the IPO product pipeline, we just launched the Arbitrum wrap staked ETH pools and the stake rate swaps on Arbitrum. So it's the first time that you can trade these instruments on a less gas intensive layer. Right now, actually just past governance, is an ETH pool. And so this ETH pool is the IPO protocol's first step into liquid restaking. And this will underwrite the Ethereum borrow rate. So if you look at this, the Ethereum borrow rate and the staked ETH stake rate swap, this is the leverage looping protocol that will be able to underpin these nice structured products. And then in the future, there will be other pools that will be underwriting different restaking rates. And then again, the USDM is a SOFR swap. So we see this SOFR swap, which is a TradFi dollar index, as the conduit by which liquidity enters from traditional finance into DeFi. And so this is setting a little bit of an example of, I think, where the major narratives in 2024 are converging, where the capital will flow in from the outside into DeFi, and where inside of DeFi that you can really look to get these nice interplays between different yield profiles. So IPO Labs, we have a sizable team, very deep background in enterprise software development, a lot of mathematicians, people from hedge funds. Myself, I've been building in crypto since 2011. My co-founder since 2016. So we have a very long view to this industry. It's not an easy project to deliver, but this is something that, if we look at the importance of interest rate derivatives in traditional finance, this can be something that the credit markets, not just next year, but 5, 10, 15 years in the future can be built on. The other thing is, if you're interested in the IPO community, we actually have a very strong community that's already active. We have 3 governance proposals that have gone through in the last 2 weeks. If you guys are interested in getting involved, there's the IPOrian group, which they've worked their way up. And these are really kind of the the community stalwarts. There's an economic work group which manages things like DEX liquidity. It manages things like emissions of rewards. You have the governance work group, you have a marketing work group, and pretty soon we'll be setting up a market and models work group, which is really focused on the quantitative modeling and risk parameters of the IPOR protocol. If you guys are interested, check out the IPOR app. You can scan here, go to app.ipor.io. All our documentation is on ipor.io. And yeah, I think that's it. I'm very quick over time. So if you guys have any questions, I'll be down here at the stage afterwards. Thank you very much.
sec, 1 sec. Oh, that's bad. I was like, am I going blind? Can you see it now? Yeah, good. Hey. Yeah, test that thing. They say it doesn't always work. I'll be right. I got it right. It doesn't
Hello, good afternoon. My name is Brian Robbins. I am with Coinbase, and I'm here to talk to you today about powering progress via partners. Basically, what kind of technology we use in our staking platform, and how the different ways that we look at the underlying technology, the types of blockchain technology that we use, and overall the way that we think about things and look at the different technology options that are out there, and how that leads to the types of decisions that we decide to make with them. So first, I'll start off with a little bit of background. I lead the engineering team for our Coinbase Cloud Staking. This is all of the validators that we run for our internal customers, our prime clients, retail, as well as a number of our external customers. My teams operate validators and all of the tools and tech that support this operation. So we run validators across over 15 protocols that represents over $15 billion in assets that are staked. And we've been doing this since 2019. We started running Ethereum in 2020. We've one of the longer staking operations that's out there. It's really about doing this at scale and doing this really well. And, for further background, Coinbase, we're known as the most trusted name in crypto. This comes from one of the most important things that we do. It's always about trusting and making sure that our customers can trust us. It's having the security and reliability, making sure that that always comes first. And the number one thing that we can do is make sure that we protect the assets and protect the networks that we operate. That's something we take very seriously, and that's always our first job. Job zero is making sure that we take care of customer assets, and that's how we protect ourselves as being the number one trusted name in crypto. After we get past that, we start talking about scale. I mentioned the 15 different networks that we operate, the large number of assets staked, and it means that we need to do everything and think about the scale of operations that we bring to the table. It's really about bringing efficiency, the highest levels of performance across all the networks that we operate, and trying to do that with as minimal human effort as we possibly can. We need to not just throw people at the problem, we need to be able to do this reliably and with scale. So looking at how do we eliminate the manual operations that are out there, the one-off processes. It's all about repeatability. If we have to do something once, that's fine, but if we have to do it more than once, we're going to write scripts to do that. We're going to create tools to automate those processes. And overall, we think about this as humans exist to introduce errors, so we try to minimize the opportunities that humans have to introduce those errors into the systems and the things that we do. We consolidate our tooling as much as we can, try to consolidate our configurations, and it's really about trying to use the same tools across all of the different networks that we operate. Because ultimately, if we can get to a place where many of the operational issues that our teams face don't require deep network experience, that lets us scale. It lets us scale the people, it lets us scale the tools, it lets us scale our operations a whole lot better. And ultimately, that's where we are at, is that many of the operations issues we have today don't require that deep network expertise because we've done a good job building out some of these tools and trying to eliminate snowflakes or places where we have a unique setup for one protocol or one validator, trying to minimize and prevent that from happening as much as we possibly can. And all of these are the ways that we bring to the table so that we can operate at the scale that we need to. So bringing that to the underlying technology and some of the choices that we've made here, first off, we're multi-cloud, multi-region. Again, large number of assets, large number of protocols. We primarily host through AWS, GCP, and we also further decentralize through multiple regions. We have regions across Asia Pacific, North America, and Europe. So again, making sure that we're decentralized across the full footprint that we can within both AWS and GCP. And it's all about ensuring that there's no single place where a failure can take down everything. We have to accept the fact that there are places where an AWS region may go down, a GCP may have networking issues. We need to ensure that regardless of what happens there, our networks and our protocols and the validators we run are resilient to those kinds of errors. And this helps us build and scale quicker. Building on top of AWS and GCP, especially really early on, back in 2019, 2020, as we were getting this started, let us not focus on how do we set up and maintain these machines, but how do we just sit on top of AWS and GCP, not have to worry about that underlying hardware. This was a really big part of our early growth, and now we feel like it really helps us scale and make sure that we have a nice, mature, scalable platform to build everything on. But it's challenging. If you've ever tried to build things on AWS and GCP, there's a lot of differences there. They're not exactly the same. And so this is where we bring in Kubernetes and Terraform. And so using EKS, GKE, this lets us build everything on top of the cloud providers and lets us normalize away a lot of those differences and the changes that are between it. We also very much bring to the table infrastructure as code, build in our infra, our metrics, alerts, dashboards. Everything gets configured. Everything gets set up through code so that we can easily recreate things. We can manage the change. We don't, again, have snowflakes. We don't have one-off processes. We don't have a lot of manual errors that can get put into the system. Again, all of this bringing back to how do we scale better and how do we bring this stuff together. And it's about abstracting away these differences and making all of the different protocols, all of the different places we host look as similar as possible to each other. And then sitting on top of that, coming up the stack again, one step above it, is our CI/CD platform. So we use Concourse CI. This manages all of the builds and tests and all of that kind of process. We also built something out that we call protocol pipelines, and this is a set of internal framework that sits on top of Concourse. It's very specialized for protocol deployments. It helps us set up the test suites. It helps us set up the staging environments, the test nets, the main nets, build out all of our deploy groups, all of this stuff kind of sitting on top of Concourse CI. Again, bringing it back to how do we do this at scale across all of the different protocols that we work and operate. And then we have a bunch of other internal build tools that we've built out over the years, mostly, again, looking at what are things we have to do more than once, and anything we have to do more than once, we look at how do we build a script, how do we build a tool around this, how do we make it repeatable so that it can either do it automatically or do it at the push of a button without needing a human to kind of go in and manually set the right parameters and configurations every time they need to go do something that we're going to do regularly, day over day, week over week. So coming up the stack, one more step, I want to talk about one of the pieces of technology we introduced in the last couple of years that has really been one of the largest unlocks for our team and the scalability. We call it Protocol CDK. And this follows the AWS Cloud Developer Kit model, or the AWS CDK model. And what it did was it brought a single language, TypeScript in our case, and through that interface, we now configure every protocol that we work with. Prior to this, if you were setting up a protocol, you might be dealing with 4, 5, 6 different languages, depending on the protocol, depending on where you needed to go. You had various configuration files, a bunch of different technology places. And once we introduced Protocol CDK, we got that down to one single place, generally one single script. So anytime you're changing something with any of the protocols that we operate, you can do that in one place. It makes us build faster. It helps us actually onboard protocols when we're launching new chains and new networks. We do this 3 to 4 times faster than we did before. But more importantly, we do that with even higher confidence. We're able to bring in the same set of testing suites. We're able to bring in the same set of alerts and metrics and alarms. All of that stuff comes in for free because we have it built within CDK. And just by virtue of using this tool set, we've simplified that work. We've abstracted away a lot of that work. So we move faster and more reliably at the same time. And this has been, again, a massive unlock for our teams over the last couple of years and really has helped us scale and get to where we are today. So that's some of the kind of generic technology that sits underneath our stack. Next, I want to talk a little bit about some of the blockchain technology and some of the things that we're excited about, some of the things we're looking at, some of the things that we've introduced over the past few years. So first up is MEV. And we started with Flashbots. We introduced this in 2022. We've since then introduced a lot of multiple other relays. We had Jito for Solana. And the goal here is really we wanted to increase the yield for our customers. But we also, being very crypto native, we want to make sure that we maintain proper proposer-builder separation. And this is, again, one of the things we're trying to pay attention to is when we're looking at technology, what does it do for our customers? In this case, MEV helps increase the yield that we have for customers. But we want to do this in a way that sticks to the ethos of crypto and make sure that we stay credibly neutral. We want to keep everything very aligned with the mission and the ideas behind the folks that are trusting us to help operate these networks. And ultimately, we've seen a lot of success with MEV. It has increased yield, it has brought better returns to our customers, and we're able to implement this and do this at scale. Something that we're paying a lot of attention to now and looking at, as I'm sure many of you are as well, is restaking. So looking at EigenLayer, obviously, there's a number of other players in this space too. And the idea of restaking, if you're not familiar with it, is you can take the ETH that you've already staked on a validator like Coinbase, and you can then go restake it and basically commit and use that, that asset to help secure an additional use case. And those additional use cases could be things like a data availability layer, oracles, other networks, which is kind of similar to the way Cosmos Hub works and the consumer chains they have there. But this is a place where it also introduces a huge amount of complexity. There's a ton of unknown risk. You're allowing the eigenlayers or the restakers to have the ability to slash your tokens again as a result, as part of the trade-off of using it to help secure their network or secure their additional tokens or tools that they want to introduce. And so this is a place where we have to be very careful and pay attention to the balance of innovation, security, and reliability. Security is always up front, and security is always first and foremost for us, but we have to pay attention to innovation. And ultimately, we would like to increase yield for customers. And we see restaking as a great way where there will be lots of opportunities to go ahead and increase that yield, but we've got to make sure that we're doing it in a way that makes sense and doesn't introduce too much risk into the products and the tools that we're offering. And as we're looking ahead a little bit further, DVT, this is something we were talking a lot about last year here at ETHDenver, something we're still very excited about. There's tools from multiple providers. Obol, SSV are two of the ones we've paid a lot of attention to. Super interesting potential here. The idea behind DVT is that we can, instead of having a single validator run an ETH node, we can distribute that across multiple validators, maybe a set of where we need 3 out of 5 to run or 4 out of 7 to run and be online. And that gives an operation like ours the ability to scale even further. It lets us do the kind of maintenance and upgrades and security patches that we need to be doing, and we can do that without ever having to take a validator offline. One of the most important things to us, again, security, means that we have to stay on top of security patches. We have to stay on top of everything that we need to do to trust and keep everything reliable. And tools like Obol, SSV, and the DVT that comes in may let us do that and may let us increase that security posture and do it in a way that lets us scale reliably. But it also introduces a very complicated extra layer into our platform. And this is why we're still paying attention to it. It's still something we're looking at because that complexity piece hasn't been worth it for us yet, but it's something that I'm still very excited about looking ahead. And that kind of brings us to the way that we make decisions and what are the key things that we're going to pay attention to. I've talked a little bit about some of these as we've been going today, but it really comes down to 3 major components. And the first is trust. Security and reliability is always the number one, first and foremost thing that we can do. That's the number one thing we have to pay attention to. When we're looking at something like Obol and SSV for DVT, some of this comes back to the teams and the underlying teams that are building it. As we're looking at restaking and EigenLayer, not just the EigenLayer team, but which AVS operators are we going to potentially introduce? Which projects are we going to allow our customers to support? And we need to understand we do have a role here with our limited bandwidth that we can't just adopt everything. And so one of the first big places that we're going to pay attention to is who's the team behind it? What does their code look like? How are their development practices? And is this something that we can trust? Where it comes to smart contracts, have those smart contracts been audited? Are we able to look at the code? Are we able to give our own stamp of approval onto the things that we operate and bring into the platform? Because again, security has to come first, and there's nothing that we're going to put before trusting and taking care of those customer assets. The second piece we pay a lot of attention to is the operational impact of what we're introducing. Again, large scale, lots of protocols. We're very careful to introduce snowflakes and prevent that from coming into our systems. And that means we need to pay attention to the operational impact. There's some of the protocols that we've operated and have actually decided to stop operating over the last couple of years, primarily because they were so difficult to run. They were so hands-on. They did have so many challenges and so much impact on our teams and on our ability to run them effectively that the trade-offs didn't make sense anymore. So we're going to pay a lot of attention to that operational impact. Part of my job, a big part of my job, is to protect our team, protect our operations, and this again comes back to protecting our customer assets. If a team is up all night, every night, dealing with issues because something that we've deployed is unstable, that makes them less likely, less able to respond to things during the day. And we've got to make sure that we keep our team fresh. We've got to make sure that we keep our team operating at the highest level possible. So we're very sensitive to anything that'll reduce the operational impact or operational effectiveness of what we do. And the third thing is customer impact. You know, after we've taken care of security, after we've taken care of the operational impact, what is it doing for the customers that want to use our services? Is it increasing rewards? Is it bringing more optionality for customers? We are here to serve our customers, and our goal is to make sure that we're taking care of the networks, the primary networks that we're doing, and that's really on behalf of the stake that our customers are putting their trust in us to represent. And so we need to make sure that we're delivering the things that our customers are looking for, that we're offering the opportunities that they want to see, and that we're giving them the chance to be able to allocate their assets to help protect the networks and tools that they're most interested in and excited about. So that's really what it comes back to at the end of the day when we're looking at what are we going to support. It's what do our customers want? What's the operational impact, and can we trust it? Can we trust the team? Can we trust the technology and everything else around it? And that really kind of wraps up a very quick highlight of how we look at things at Coinbase and the way that we approach our staking business and our validator infrastructure. I really appreciate your time today, and I'll be over here on the side for a few more minutes. If anybody has any questions, I'd be happy to talk to you. Thank you.
Cool. Let me make sure we've got video.
Yep.
Cool. He says we're not getting that yet.
Maybe that is the keyboard, but oh, maybe not.
Cool. We're good.
Awesome.
Just gonna go ahead and swing up. If you want Oh, you said you're probably not going to use the clip.
No, probably not.
Okay. Fair enough. Cool. Well, this microphone is on. Let's throw it out there whenever we're ready. So we'll just let that timer run all the way down. It has to coordinate with the live stream.
Makes sense. Okay.
So, cool. Let's see. Oh, you said that you're probably going to stay planted here. If you want to walk around, you can.
Yeah, maybe.
If you're going
I'll do 1 minute.
well, I was going to say, like, if you want to walk around the stage as you proceed.
I see what you're saying. Yep.
If you're in front of the
No,
screen.
again, the problem is I don't remember the slides, so I'll be looking like this the whole time I do it if I do that.
Yeah, if you do end up out front,
Try not
in
to
front of
fall
the screen.
off, and then the line.
Well, just like, you can walk anywhere on this line. I'm not going to. Not closer to the screen, because it just needs to play over.
Focus.
Cool. Feeling good?
Yeah, yeah.
Cool. Well, we will start in 3 minutes and 47
Awesome.
seconds.
Okay, hold on. Test, test. Go. Sammy, you're watching my backpack, right? Our security guy. Hey, what's going on, everyone? Welcome to my speech on Rise of the Hyperchain. My name is Daniel Lumi. I'm the Senior Product Manager of ZK Stack, built for ZK Sync. So today we'll be talking about our vision for scaling the blockchain to mainstream adoption. And first I'll go a little bit into what is Matter Labs and how does it relate to ZK Sync. So Matter Labs is one of the leading ZK companies. We've raised over $250 million, and we have over 150 experts in engineering and cryptography. We really have a world-class team with people from SpaceX and Microsoft and Google and Uber. So ZK Sync is an L2 built on top of Ethereum that uses zero-knowledge proofs. We as Matter Labs were the inventors for ZK Sync, and now we're one of the main core contributors. There's also a lot of other core contributors, such as Lambda and Transaction Fusion and many other ones. So our goal for ZK Sync is to essentially make a safe and easy-to-use blockchain that is always cheap, regardless of the scale that it goes to. And this is very important to do these things without compromises. That's why we're all in blockchain. That's why we're all in Ethereum. So the state of blockchains today, and yeah, I'm talking about dilemma, not trilemma, before you bounce on me, dilemma, okay? So how does the internet scale, right? And this will explain the dilemma, right? And so just as a mental model, imagine that you're playing a game on your computer, right? That might work, assuming you have a good computer. And then you start booting a bunch of other applications, and at some point, like you simply cannot run every single application on your computer at once, right? So how does the internet deal with this? So let's say there's a bunch of people that want to order a new iPhone, to pre-order it. So maybe it works for the first 1,000 people. But at some point, it's going to be too many users entering the website for it to all be supported by one server. So essentially what they do is they copy the state of the Apple website onto many different servers, and then they can scale sort of limitlessly, horizontally, and everyone can get the website. So the internet, if you allocate one server with n resources, it has 1x scale. If you allocate another, let's say 3 servers, then it has 4x scale. So it scales linearly according to the amount of resources allocated to it. So how does blockchain scale? Well, the important part and the whole point of blockchain is that you need to form consensus. Every single server on the network needs to re-execute every single transaction of the network. And this will happen thousands or tens of thousands or hundreds of thousands of times, depending on how big the network is. And similar to the internet, we can't support all of the world's blockchain transactions and applications on every single one of those servers. Like, this should be really obvious, and if you're being told that you can do this, it's probably a dishonest or just ignorance into how computers work. So this is the problem that every blockchain has, essentially. They need to balance between decentralization and scalabilities, because if they make it too scalable, then maybe 2 computers in the world can run it, or at some point that computer, like, you won't have any computers in the world. It can't go infinitely bigger, right? And you're sacrificing decentralization. So Ethereum decided to focus on decentralization. Keep the scalability really low so we can make it maximally decentralized and secure. As a L2, ZK Sync can essentially inherit the decentralization and then focus on scalability instead. So again, every single computer needs to run every single transaction. So if you have 1 computer on Ethereum network, you have 1x scale. If you have 10 computers, you still have 1x scale. If you have 1,000 computers, it didn't scale at all. It got more decentralized, but that's not going to support the world's transaction throughput. So how about cross-chain? Maybe we can just scale cross-chain. The whole point of blockchains is to have a global state that doesn't have trusted entities. If you start doing cross-chain, you have trusted entities. That defeats the purpose of having blockchains in the first place. That's not the way. That's not how we scale blockchain. Okay, so it's all over. We should rage quit, get jobs in banks, right? Sorry, Vitalik. I'm sorry, we tried. No, don't worry. We came up with a concept called the hyperchain, right? ZK is the end game. We'll get back to this. So the hyperchain essentially consists of two different layers. One is the core, and one is something I just wrote for this presentation. It's a framework, a Web3 framework that ties those cores together. So let's start at the core, right? And ERA is actually an L2 that was built on the technologies of our core, right? But every single hyperchain can leverage those same core innovations at the heart of the hyperchain. So anything that is done on ERA benefits literally every single other hyperchain. And here's some core features. We'll go into these a little bit. The first part is we have unprecedented scale and low fees. So unlike other L2s, EVM L2s, we didn't build the virtual machine one-to-one. We're not trying to prove every single opcode. We optimize for high performance because we want this to reach mass adoption, not just like 10 people trying to spam transactions at once. Like, we need to make this much more scalable to reach 1 billion people or more. So with our virtual machine and our technology, you can currently support 100 to 200 transactions per second, depending on the complexity. And that's compared to like all the other EVM L2s of 5 to 20 maybe. And we have much more incoming in the future because we architected it that way. We do have the lowest fees of any L2. In some cases, by up to 10 times cheaper. With Validium, not just in L2s, we'll have one of the lowest fees in all of the blockchain industry if you understand how subsidies, gas subsidies actually work. For a ZK prover, you can also run it on consumer-grade hardware. So you can run it on a computer with as little as 6 gigabytes of GPU RAM. That's just about any laptop at this point. There are some other requirements, but that is impressive. That's actually a couple days ago, we updated a caching layer for that. Unlike other L2s, we don't publish every single transaction onto the network. We publish the delta, the difference. So if I send you 10 bucks, you send me 10 bucks, I send you 10 bucks, you send me 10 bucks, nothing gets updated. Because I just end up with 10 bucks in the end. If it would have ended up with you, we would have published that one change rather than every single transaction between. So that makes every single transaction cheaper, but it also enables certain things like super high frequency Oracle updates, like really high frequency trading, super cheap NFT mints in batches. It allows reoccurring payments, like we can do on-chain privacy using state diffs. So another core feature that we have that other EVM L2s don't is we have native account abstraction, right? And this essentially allows you, like if I'm sending you 10 USDC, I don't have to even think about what ETH is. I don't have to have any ETH on my account. I just pay the fee in USDC, and you end up with USDC. And this works on any wallet, including MetaMask, any EOA wallet, as well as any smart contract wallet. And then you get some cool other things with smart contract wallets, like social recovery. You don't have to write down 24 seed words anymore. Like you can sign a transaction with your iPhone, and you can have things like session keys or limits. And I do recommend, Clave is over there. Go get their wallet, try it. It's fucking beautiful. Sorry, I don't know if I'm supposed to curse. It's really cool. It's really, really cool. With Validium soon and Porter later, you also get essentially fixed gas costs for transactions. So right now, the vast majority of your fee for making a transaction is publishing data onto L1. Instead, we can essentially publish the data somewhere else, use zero-knowledge proofs, and then you get more or less a flat trading fee, regardless of how much Ethereum usage goes up. It's always going to be 1 cent or less for every single transaction, forever. It's actually scalable and sustainable, unlike some other blockchains that subsidy fees. That's the real fee. And we focus on security first, right? It is our #1 priority. We spent $6.5 million in audits just on ERA, right? With ZK, you don't have to trust validators. You can just trust the math. And something that we're going to announce here in Denver is also if there's an implementation bug in ZK, we'll do two-factor authentication or multi-prover using essentially a trusted chip. So even if there's a bug, no one can steal any money from the L2. We are already obsessed with developer tooling, developer experience. but we're going to make a massive push this year to really, really further it. So we already have Foundry, we have Remix, we have Hard Hat, but we have so many other efforts coming this year. I think developers, you'll see a massive difference in using ZK Sync or any of the hyperchains built on top. So these are, like, as a community, I know it's hard to understand how is one L2 different than the other L2. But there's thousands of choices that we make on a day-to-day basis that compound, and it grows and it grows. We have been building this system with world-class experts for 5 years. Like, most of these features that I just mentioned, you can't just slap on another L2. Like, these are fundamental architectural choices that went into building ZK Sync, and it's part of the reason why we really believe this is the most viable solution for mass scale. And so here we have it, the core of every hyperchain. There is customization, but it is the core underlying technologies that will enable mass scale. So then comes, like, now these are separate L2s, so how do you tie them all together? And that's where ZK Stack comes in. That's my product. Think of it as a framework, right? It makes it really easy for you to spin up all the different hyperchains, but it's also the layer in between, making essentially interoperability seamless where you as a user don't have to think about it at all. Right? And ZK Stack, it's a modular, yeah, okay, good, but it was loading. It's a developer-friendly modular framework that makes it really easy for you to deploy and customize hyperchains without having to spend 5 years rebuilding the technology and 6.5 million in audits and all that. So with ZK Stack, you can fully customize a lot, just about everything about your hyperchain, right? You can choose where the data's stored. You can have your own custom gas token. So if you want to launch a token and be the gas, you can do that. Like, you can use different sequencing layers. Like, you can publish the data publicly or keep it private. And there's many, many different changes that you can make to the decisions that Era as a L2 had. And ZK Stack essentially makes blockchain future-proof. This is the key to scaling blockchain to mass adoption and getting it to scale like the internet does, horizontally, essentially limitlessly. And the key piece there is the interoperability, right? And that's where the zero-knowledge magic comes in, right? You can't do this without ZK. And if you use ZK, essentially all of these different L2s can communicate to each other in the matter of seconds or minutes, and essentially allows all the different hyperchains to tap into the same users in liquidity. This one might take a bit. It's a video. Ah, okay. So let's say you have your money on one of these hyperchains, and you have ETH there, and you want to swap it for USDC on any of the other hyperchains. You sign one transaction, it goes there, it swaps it to USDC, for example, and then it returns the money to you. And it's all in one transaction. You don't even have to really think about where your money is, where the DEX is. It just kind of works. And this is the thing that enables this massively scalable, essentially supercomputer. You can abstract away the complexity, and you can actually scale essentially limitlessly. Anyone on any chain can interact with any other chain. You can have hyperchains that use many hyperchains for front-end, database, something else, users, and it can kind of shard itself. You can have DEXs that exist in different places, and it makes this similar to the internet. You plug into your Wi-Fi, and you can use any server in the world without having to know its IP address. ZK is the end game. Like, this is not a marketing message for us. We really do believe that this is what enables mass market adoption of blockchain. And so here's our sort of current hyperchain ecosystem. And here's some examples. So Kronos is launching a hyperchain. They're backed by Crypto.com with an addressable user market of over 80 million people. We have ZK Candy. It's the largest game developer in all of Southeast Asia, as well as New Zealand and Australia. We have Tradable, who's bringing RWAs on chain. They're working with partners with over 9 billion in originations. And we have Gravity that's building an amazing, essentially decentralized derivatives exchange. And there's so much more. Like, I wish I could tell you guys, the people that I talk day to day, we're talking with so many partners that are committing to launch. This is the first time that, like, I'm really excited. It's not anymore an online casino. If you saw the partners we're talking to day, these are mass market adaptation. Like, people are reaching out to us that used to make fun of crypto or not understand the value of decentralization. It is gonna get exciting in the next years. And the thing that I think people don't understand about this sort of app chain, hyper chain models is if you have just one other app chain, it doesn't just grow the network that much. If Chronos comes, brings their users in liquidity, and the usage of the network goes up, every other hyperchain benefits from that too, right? So every time you launch a new hyperchain, it essentially contributes to exponential growth, not linear growth, right? This is similar to Ethereum. You don't just have one core group of people making applications on Ethereum. It's everyone developing, and the more people develop, the more it grows exponentially. Everything we do as Matter Labs for ZK Sync or for ZK Stack, we follow something called ZK Credo. It's our pledge, our morals, our values in this ecosystem to protecting Ethereum, to protecting the user, to keeping the system decentralized, to keeping it from being hijacked. Everything is open source. Will be, is, will be, and forever will be. You can always use it. Everything's permissionless. You don't need anyone's permission to launch on this. You don't need anyone's permissions to withdraw your money. Oops. Come play with ZK Stack. Like, launch onto the hyperchain. You will experience the same exponential growth. You can go to zkstack.io or scan that, and you can start playing with the future today. And it's out today, by the way, so the future is now. I really encourage you to try ZK Quest 2.0. It's a new learning and quest platform. Every builder here in ETHDenver, part of the hackathon, can get up to $230 in Ethereum, NFTs, some swag. And essentially, it teaches you about blockchain. It teaches you how ZK Sync works. Like, I really encourage you to play around with it. It's super cool. You should follow ZK Sync on Twitter. You'll hear all the updates, and you can also follow me on Twitter, X, whatever, by either scanning that or ZK Lumi. And ZK is the end game. Like, this is it. We figured it out. We're finally scaling blockchain. And please feel free to download this presentation, do whatever you want to it, share it. Like this is an exciting time, and I think like normal people will start understanding or just using blockchain, whether they have to understand it or not. Like, we're at the epicus. We are about to launch into mass market. That's it. Thank you.
All right. Hi, everyone. I'm Mike Nathanson with Abundance Protocol. And today I want to talk about how blockchain technology can prevent dystopia and create an economy of abundance. So we have a lot of crises that we're dealing with today, and we can think of these, the reason we have these crises and why they're getting worse, as a problem with feedback loops and exponential technology. So if we think about what makes an effective feedback loop, we can think of markets, for example, and what makes markets effective feedback loops is that if you're doing something beneficial, there's an incentive that rewards you to keep doing it or improving on it. And if you're doing something harmful, there is an incentive for you not to do it. There's a cost to it. So if you're producing something in the market, you have customers. If they buy it from you, obviously you get the money back, and then you can reinvest it in whatever you're doing. You can improve it. You obviously want to create more of it to produce more. If you're producing something that harms people, they're not going to buy it. And if they don't buy it, then you don't get the money for it, and then you cannot, reinvest it in anything, so you don't want to do it. We don't have the same feedback loops for either negative externalities, which is things that are harmful to outside the market, or for public goods, which means if you're creating a product and that product harms others, whether it's through pollution, or if you're a social media company and you're creating a toxic social environment, there's nothing really there that would put it as a cost on you. Instead, you're making the money, but there's no cost. And the same thing for public goods, which is basically there's no economic incentive for you to create more public goods because you don't get rewarded for it, so you're not going to make more of it. I mean, you might, but you're not getting the benefit from it. And if we put it together, if we put the externalities, the market, and public goods all together, we understand how this whole system works, that basically you have an effective feedback loop in the market, and you have an incentive to offset some of those costs through externalities, but you don't have an incentive to produce the public goods. You still might do it, but you don't have the economic incentive. If we add the exponential technology to it, then we can see why there's more externalities. Because now every little change you make, it can have an exponential effect, which means you're making more money in the market, but it produces more externalities. And that's where we are. But what we actually want is we want to have effective feedback loops and to reverse this process. We want to have an incentive to produce the public goods, and we want to have a disincentive to produce the negative externalities. So the question is, how can blockchain technology help in this process? How can it help create those effective feedback loops? So this kind of goes back to the 4 different quadrants of goods. So if we have private goods and club goods, there is effective feedback loops for them because they're excludable, which means you can create a market for them. You can sell something and then you get money in return, so there's effective feedback loops. For common goods or public goods, you don't have the same process. You produce something, but there's no way for you to capture that value. And if we think about it in terms of let's say a book, if you're creating a book and you're selling it in the market, then you can create a physical book and then it can be a private good. Or if you take the same content of the book and then you sell it online, then it can be a club goods, which basically means that people can either subscribe to you and then get the book, or the idea is that it's non-excludable in the sense that the content, many people can just view the same content. It's not restricted. And then you can take the physical book and donate it to, let's say, to a library, and then it becomes a common good because people can still only take it one at a time, and it also degrades over time because the more people use it, it degrades, so that becomes a common good. And you can take digital content and then make it available for everyone, and then it's a public good. Now, if we think about that book in those different quadrants, we can see how if it's a public good, it has the most impact because the most people, you need the least resources, and then the most people can access it, but you make almost no money or no money from it, versus if it's a physical book, you need to produce more of it, you need to kind of consume more resources, but that's how you can make a lot more money. And you can see, so in terms of impact and in terms of efficiency, you obviously want public goods, but we have a conflict now with how much profit you can make, and therefore, you know, your own self-interest. So how do we change it? Do we change the profit to go into the impact? How do we make them in the same quadrant? So we can look at the different funding mechanisms we already have. We can look at the traditional ones and the crypto mechanisms. And in traditional terms, we have government, we have philanthropy, crowdfunding, and then all these, they still don't create these effective feedback loops that we're looking for. It's still, you take money from the left-hand quadrants. If it's government, you basically tax people, and then you take that money and you put it toward public goods or common goods. But there's no, the more you create the public goods, you're not gonna have more money going toward that. In crypto, we have new mechanisms that enhance existing systems. So for example, quadratic funding, it's a much more effective way to distribute funds based on the interests of the community, but you still need this external source of funding for it. So it's still, you don't have the effective feedback loops. Retroactive funding is also, it's a new mechanism where the idea is that once a public good or a common good already created the impact, then it's easier to assess the value of that impact and then reward it. But currently, we still don't have systems that fund it in an efficient, not an efficient way, but in a self-sustainable, there's no feedback loop there. You still have like optimism, you still use sequencers fees, which are in a sense like a private good. And then we have consensus mechanisms. And consensus mechanisms, there's different ones, of course, but that's the first mechanism that we see a self-sustainable loop created. We have a feedback loop where we have one common good, which is network security, and you can self-sustainably fund it in the sense that you don't need external funding from it. It comes from basically coin issuance through the protocol itself, and the reason you make it sustainable is if either you take the money back in a way, like you reduce the supply, so either the supply is fixed or reduced when you use the blockchain, or if there's growth in the demand for the blockchain, and then you can make it sustainable. But this only works for one specific common good, which is network security. But what we want is we want it to be effective for every common good or every public good. So if we look at the mechanisms we have right now in terms of their scale, we can see that the traditional mechanisms, if it's government, it's in the trillions, and then you have philanthropy or crowdfunding that's in the billions now. But crypto, it's still, for both quadratic funding and retroactive funding, it's still in the tens, hundreds of millions, but it's nowhere near where we need it to be. Consensus mechanisms, on the other hand, is over $1 trillion right now, because if we look just at Bitcoin and Ethereum, those two already managed to generate, for those providing the common good of network security, about $1 trillion in issued to them. So what we need is, how do we, taking what we have now, how do we make a system that works like the market, which is it's efficient and you have effective feedback loops, but that works for something that's a public good. And for that, we introduce something called value consensus. And the idea is to take a similar process like consensus mechanisms, but instead of the way consensus mechanisms work is basically you have one decision that nodes in the network have to make based on what a block proposer does. So a block proposer produces new block, and then the nodes in the network basically have to decide, did it follow the rules of the protocol, yes or no? And if it did, then you issue a reward from the protocol to that producer. But what we want is we want a mechanism that works like the market, which means that you have a contributor who creates a public good, and then an ecosystem rewards the contributor for that public goods based on the impact on the ecosystem. So you want to create a market around that. But how do you create a market for something that is a public good? Like you produce it, but there's no need for you to pay for it because it's already created. So the way it would work is because of repeated games. And the idea is that you reward the public good because you want more of it produced. You want more public goods produced. Not exactly the same one, but any other type of public good. And if you produce it in a way that you reward it, then you're going to have more public goods created for your ecosystem. And you want to maximize that because that creates the most impact in your ecosystem, which means you have the most economic opportunity when you're in that ecosystem. But you want to balance that with maintaining your currency value. So you don't want to overpay for the public good. And if you have both, then you can have an alignment of interests. And that's one of the key things you need to be able to reward public goods in a way that's credible and efficient. You need both data, because if you don't know the impact, then you don't know how to reward it. So you need the data, but you also need an alignment of interest within the ecosystem, because it doesn't matter how much data you have, if the ecosystem cannot agree on what value this product has for the ecosystem, then you cannot agree on how much it's worth and how much you reward it. But if you have both, if you have the alignment of interest, which is what we described now, and data, then you can have impact equals profits, and then you can create an effective feedback loop around it. And another way to look at it is if you under-reward the public good, then you're going to have less of it produced, which means the value of your currency is going to be not as high. Versus if you overvalue it, then you're going to have users leaving the ecosystem. And if users leave the ecosystem, then also you're going to have less value for the token. But there is a shelling point where you reward it accurately based on how much the ecosystem values this public good. And if you can do that, then impact equals profit for this ecosystem, and then you can have a mechanism that works. But that's just the tokenomics. There's still a lot of challenges of how do you actually do it. So you need to design a mechanism that's self-sustainable, which we already described what you would need for that. But how do you make it self-sustainable? Well, you need the currency value to be stable. And for that to happen, you need to credibly review the impact. And you need the system to be scalable, but to credibly review the impact, you need to have Sybil resistance and you need to have collusion resistance, which means that you cannot have a system where someone proposes a project and then the people who review it collude with them to just reward them, because then there's no credibility to the evaluation process. And you need scalability, which means that if you have maybe 5 projects in a system, everyone in the ecosystem can review it. That's not a big deal. What if you have 100 projects, 1,000 projects, 1,000,000 projects? How do you make this ecosystem work in a way that you can scale it? If you have everyone in the ecosystem reviewing every project, you cannot do it. So I'm not going to go through every single problem for the mechanism how to solve it. I can assure you that we have a solution. It's in a white paper, but I'll go through the major ones, which is the scalability and the credibility. So for the issue of credibility, we want retroactive funding, because that's when you go with retroactive funding, then you can basically reward a project based on the impact that's already created. But the way you do it is you want people rewarding it that are domain experts, and you also want ecosystem-wide people looking at the project, because every domain expert thinks that their domain is the most important one. But you don't need everyone in the ecosystem reviewing every project. All you need is the impact that the project is likely to create. You need expertise that's sufficient to review it. So if the project is only likely to create a little bit of impact, you don't need a lot of expertise. You can have like a little bit of expertise. And if it's likely to create a lot of impact, obviously you want a lot more expertise going toward reviewing it. And you want the people reviewing it to be randomly selected, so then you wouldn't have collusion between the proposers and the people who are reviewing it. So, but to have this efficient allocation of validators, of reviewers, for that you need prediction markets, which means you need an incentive for, just like you have in the market, incentive for people to look for the projects or the stocks that are likely to make the most money for them. You need incentives for people to look for projects in this system that are likely to have the most impact. That's number one, and also to review them accurately. And if you have an incentive to do that, and we describe it in the white paper, then you can have resources in the system going towards reviewing every project based on their expected impact, and then the whole system works. And that pretty much is a way to solve every one of the challenges for this ecosystem and for this mechanism to work. And then, and again, I didn't describe all the issues, but it is in the white paper, and we can go from there. But once we have that, then you can have effective feedback loops for public goods, because then you can incentivize projects to contributors to create public goods and common goods in a way that you want them to maximize their impact on an ecosystem. And if there is an economic incentive, that would create this effective feedback loop. And at the same time, you have a disincentive to create negative externalities. So essentially, you solve both problems. There's actually more mechanisms within this protocol that allow you to disincentivize the negative externalities, but I'm not going to go into all of that now. So taking a step back, kind of how do you make this whole system seamless and intuitive for people to use? So you can really take a decentralized social media platform, and you can overlay it with the ability for people to review projects, and also with the ability to create data forms that allow easier review of the projects. And you incentivize that because that's also a public good that you're creating. And so you can have a system that's intuitive, that's seamless, because that's kind of part of how we interact with the world and also with people around us, through social media, at least online. And that's how we can have a system that's seamless, that's intuitive, and also has these effective feedback loops for public goods and negative externalities. And obviously, I didn't go through everything, but sorry about that. But we are releasing the Abundance Economy book today, and you can get it either through the QR code or in the link below. And that goes a lot deeper into how we can create the system, what kind of effects it has, and its benefits and so on, and how we can make it all work. Thank you, everyone. I'm Mike, and with the Abundance Protocol, and you can talk to me if you have any questions or if you want to help out later. Thank you.
Hello. All right. Hi, I'm Austin. I work on the ASTIS MEV Boost relay. And today I want to talk about relays, the trust we place in them, and what could happen if that trust were abused. Specifically, we'll look at the worst case scenario where a relay turns malicious and tries to deliberately cause damage. So I am going to assume some background knowledge. It's going to be a somewhat technical talk. But as a reminder, relays are trusted entities that sit between block builders and proposers. The proposers trust relays to ensure blocks submitted by builders are valid and will pay the amount they promise in their bid. And once a proposer signs a bid, they also trust the relay to release the execution payload that's been private so far. Builders also trust relays to keep transactions private until they're included in a block. So we can already see some pretty clear attack vectors if a relay just decides to not do these things. It's also worth mentioning how much Ethereum as a whole is reliant on MEV Boost. Over 90% of blocks are sourced through relays, and this number has stayed pretty consistent over the last year. Relays tend to self-report their validator registrations, so these numbers do have some issues, but it's clear that there are some individual relays that have a significant percentage of the validator set connected. And since MEV Boost blocks are 5 times the value of vanilla blocks, this situation isn't going to change anytime soon. So we're going to move between a few different topics, first looking at a few past incidents to see how they work, then taking a deeper dive looking at how a compromised relay could amplify the effects of the issues we've seen so far, and finally we'll consider a timeline of events and what this could look like in practice. So first, in October 2022, an attacker discovered that the manifold relay had disabled block validation, but not secured their block submission endpoint. So they submitted bids that promised to pay a lot of ETH, but kept the actual rewards for themselves. Since the relay wasn't checking, they went ahead and forwarded each bid to the proposer, who took it since it looked like the highest bid. But each time the proposer got nothing, and the attacker got just an average block's worth of reward. In the end, the attacker got 183 blocks like this through the relay before getting cut off, and they stole about 7.5 ETH. So the next attack is the low-carb Crusader attack from April of last year, which was really interesting. It had a lot of moving parts, but the main issue was really one of transaction privacy. So here, a malicious proposer actually managed to trick the ultrasound relay into revealing the transactions in a block without publishing it first. So this gave the attacker a chance to manipulate those transactions for their own profit. They constructed their own block using the transactions from the MEV Boost block and submitted that to the network instead. Ended up making a pretty solid payday. Since the attacker was the block proposer, they knew in advance they were going to propose a block, and they were clever and planned ahead. So during the bidding for their slot, they submitted some bait transactions to the public mempool. These were generally trades on dexes designed to look like easy money for the MEV bots. When the attacker looked inside the block they got from the relay, they found transaction bundles trying to capture MEV from the bait. So to make their $20 million, what the attacker did was extracted MEV from the MEV bots. Basically, they made sandwiches. And they could also unbundle the original bundle, moving things around, rearranging as much as they wanted. So attacks like this ended up being incredibly profitable for the attacker. And there's more that could be said about this attack, but it's a very quick overview here. And there have been many other attacks, but the key takeaways here are 1, proposers can be lied to about block value, and 2, builders' blocks are vulnerable to unbundling. So now we'll look more formally at the kind of attack a compromised relay could carry out, largely building on what we've already seen. So pretty much every incident we've seen with relays historically has been the result of some bug in the relay software. So this necessarily limits the extent to which the bug can be exploited, and as soon as the relay operator realizes what's up, they'll put a stop to it. I've put the recent blocks route attack up here as well. This is pretty normal. Most attacks don't last longer than a couple hours and result in single-digit losses of ETH for proposers. It's not great, but it's not the end of the world either. The low-carb Crusader attack was much more financially significant, but it only applied to a single slot and required precise conditions to carry out, It's not really something that could be sustained. So what if this weren't resolved so quickly? It'd be very different if there were an actual deliberate attack causing a relay to become malicious where you couldn't count on its operators to resolve the issue. It doesn't have to be that the operators themselves are malicious. It could be that attackers compromise the relay infrastructure or pull off some DNS attack. Either way, they'd gain complete control over the relay for an extended period of time, and this would be very different than the issues we've seen so far. And it's not as commonly discussed, so that's what we're looking at today. All right, so here's our friendly neighborhood relay, ASTIS. For one of these reasons, it's compromised and it becomes evil ASTIS. They like being evil for the sake of being evil. They'll steal money, they'll attack Ethereum, whatever causes damage. It should go without saying that we hope this never actually happens, but we'll use it as the example today. So let's see what this would look like. For each Ethereum slot, we have a different set of options depending on whether the proposer is connected, whether builders are sending us blocks, and we'll cover a variety of potential attacks. These generally are not novel individually, but we can consider them in the context of current MEV-boost adoption and their role in a larger scale attack. So here's our base case. The proposer isn't connected to the relay. We're not receiving any blocks from any builders. The relay isn't in any sort of privileged position. It can't influence block production. So from our perspective as the attacker, this is unfortunate. There's nothing we can really do. But it's kind of a nice reminder. Relays only have as much power as builders and proposers give them. Proposers building blocks locally are the greatest defense from these kinds of attacks. In this case, we have a proposer connected to the relay, so let's mess with them a little. The proposer trusts the relay to carry out a fair auction, but we don't have to. We can just lie to them. We saw this earlier with the manifold incident. The attack there was a third-party block builder, but we can also build a block like that ourselves. We'll tell the proposer we'll pay them 100 ETH, but actually pay them nothing. Even if they're connected to other relays, 100 ETH is going to be the top bid pretty much every time. So the proposer's MEV-boost client will happily take our bid, and once they're committed, they'll propose our block. And every slot we have a proposer connected, we can carry this out repeatedly. The planned mitigation for this attack was to have a number of independent relay monitors, which validators would link to. The relay monitors would check each slot after the fact to see if this attack took place. If so, they would send out a message to all listening MEV-boost clients, making them immediately, automatically disconnect from the malicious relay. But this ended up not being fully developed, so while there are relay monitoring services out there, there's no automated disconnect. So that means validators would have to hear about the attack through some social channel and then manually modify their MEV-boost relay list to disconnect. Any validators who remain connected are vulnerable on every one of their block proposals. Large staking operators would probably catch on quickly, but I wouldn't be surprised if some smaller operators take days, weeks, months to catch on. We also have the option to just not release the execution payload. We don't make money directly this way, but we can forcibly cause a missed slot, censor all the transactions, potentially harm consensus health. In the repeated case, the relay could attempt to cause every connected validator to miss every single proposal. The solution, which is actually in place this time, is the MEV-boost circuit breaker. This is additional logic implemented in consensus clients to fall back to local block production if network health is poor. Usually, the circuit breaker condition is some number of consecutive missed slots. So if here green is included and black is missed, eventually the circuit breaker kicks in and the next proposer will locally build a block. The other condition is a larger number of missed slots in a larger sliding window, like this. So these wouldn't completely stop an attack, but it would mitigate the worst case scenario and prevent liveness failure at least. So for this proposer-connected case, these two attacks take advantage of the ways in which a proposer places trust in a relay. They trust relays to provide accurate information about bids, so we lie to them. They trust relays to release the full block, so we don't. And these could be combined as well. First, you lie to a proposer to get them to accept your block, and then you withhold it. Some fun stuff. All right, so this is the opposite scenario. We're receiving block submissions from builders, but we don't have a proposer connected. So we're mainly manipulating builder blocks. Builders trust relays to keep the transactions in their blocks private and to not exploit them for personal gain. So the simple option is copying MEV strategies and private order flow. These are generally the secret sauce that builders use to gain an edge over their competitors, and our malicious relay has the ability to not only copy the sauce, but pick and choose the best sauce from each builder submission to create a super valuable block. Of course, if we're doing all this, then we might as well take a note from the Low Carb Crusader, submit a bait transaction beforehand, build sandwiches, and break apart all the bundles. Searchers might have adjusted their strategies since the initial attack took place, but it's probably still pretty profitable. In this case, the proposer isn't connected to our relay, but if they are connected to other relays, we can submit through them. We just have to pay enough to win the auction. And if they're not using MEV Boost at all, there's not much we can do this slot, but we might be able to leverage some of this information for the following slot. There's not much a builder can actually do to prevent a massive one-block attack that comes from out of nowhere. That would provide the majority of the profit for us and most of the damage for them. But builders tend to be pretty sophisticated actors. They likely keep a close eye on relay behavior with systems in place to quickly detect these problems and get the heck out to prevent further losses. If a builder continues to submit blocks, they're placing their funds and those of any connected searchers at risk of more MEV extraction. The final scenario is just a combination of the previous two. A proposer is connected and a builder is sending blocks. This is the normal state of operation for a relay, but it's actually the riskiest. So let's put it all together. We examine builder block submissions in order to copy MEV or make sandwiches. Then we lie to the proposer, promising them a fake high reward. Once they accept the bid and sign the blinded block, they're locked in to proposing our block, where we make bank and they get nothing. We release the block, watch the chaos unfold, and repeat as we see fit. And when you look at all this, it's pretty significant, right? So for those of you running Ethereum validators, this is the real implication of adding a relay to your MEV Boost config. You're trusting the relay to not be a vector for this attack, either deliberately or through some security vulnerability. So with that, we've covered enough background on the main attacks, so we can use the remaining time to put them into context and really answer the question, what happens if a relay goes rogue? So we'll draw out a hypothetical timeline of events and see how this would practically play out. To be clear, this is hypothetical, spitballing, don't take it too seriously. Some of the broad strokes may be generally accurate, but when it comes to the details, I probably don't know what I'm talking about. Anyway, so a day comes when we here gain access to the ETHDenver relay. We decide to use our power for evil. So let's do our best to break Ethereum. So we're not going to immediately launch the main attack. That's not optimal. We'll start in stealth mode. ETHDenver's builders each have their own private order flow and MEV strategies. So let's see if we can sell that information to a third party. We can form a nice partnership with some sketchy searcher or a market maker and coast on that income for a while. At some point, maybe we're getting bored or it seems like someone's catching on, so it's time to go loud. We can try to time the attack for a holiday or nighttime in the US and Europe, maybe open a leveraged ETHUSD short since we know we're going to be causing a stir. Our attack is going to be most effective in its opening moves, so we want to make the most of it. The proposer block schedule is known ahead of time, so we can wait for a particularly good opportunity to come around where we want to see a lot of consecutive slots of proposers who we know are connected to the relay. At T-minus 10 seconds, we're one slot away from the start of the attack. So we can submit our bait transactions, lay the groundwork for some spicy sandwiches, and begin examining builder blocks and creating our own block. And now it's time. The proposer sends us a get header request. We give them the info for our big attack block along with a fake 100 ETH bid. They take the bait, they send us a get payload request, we publish the block and watch the transactions confirm on Etherscan. There's actually a really detailed timeline for the Low Carb Crusader attack, which it actually took about 7 hours for the first post about the attack to show up on Twitter and get the ball rolling. So I'm going to be generous and say that people have learned their lessons, hopefully, and would catch our attack sooner. Some entities might have automatic disconnects trigger. Others might have their phone alerts go off and would be confirming 15 minutes in that something is very wrong. In the meantime, we've had 75 slots to mostly go wild repeating the attack. ASTIS has about 2/3 of all validators connected, so that's more realistically 50 slots. But we can also expand into some fun app-specific attacks, particularly where we can use our extensive censorship options. So at 2 hours in, I would hope only a few builders would remain connected to the relay, and the searchers sending to them would either have stopped or maybe their bots would break. Some stakers have also disconnected, but there's probably a long tail of operators who haven't gotten the memo. Enough that we're stealing a steady stream of cash from the remaining proposers. Social media might catch on, network activity would spike, which might paradoxically give us more opportunities for MEV. At this point, a war room would likely be thinking this through, but there's not really anything they can do to force the remaining proposers to disconnect from the relay. They just have to spread the message. There's one potential technical solution, which is maybe have the legitimate relays try to outbid the ASTIS relay to limit our win rate. So we might be able to catch on to that and instead just bid the maximum possible integer. If the other relays copy that, then we actually end up, the tie is broken by which block hash is larger. So in the end, taken to the logical extreme, we would actually end up in a proof of work style hashing war to see which relay wins. So after a whole week, the compromised relay would probably just become a fact of life. You could imagine Dune dashboards being set up to try to identify and track the remaining connected node operators. RPCs might try to time transaction submissions to avoid those slots. But who knows, those people might be off the grid, anonymous, whatever. I'm sure some very smart people would have found more ways to reduce the chance that a connected proposer would select an ASTIS block, but it's hard to imagine them being 100% effective. So I wouldn't be surprised if it takes months or until the next hard fork for a stubborn few proposers to finally disconnect. And so while that was fun, we can step back and say, it actually really sucks. There are a few things that stand out to me. There are way too many factors to tell what the total losses to all parties would be, but given that the low-carb Crusader attack hit double-digit millions, it's probably a reasonable order of magnitude estimate. At times, the attacker would control a massive percentage of Ethereum block space, especially if this happened to one of the larger relays. There's a lot of censorship potential here, and a lot of downstream damage to censorship-sensitive protocols. There's also a chance that this could have really lasting consequences given how long some proposers will remain connected. And as someone operating a relay, I would like to not personally be a point of failure this large. So here are some possible things we can talk about to help prevent this. In the short term, the MEV boost circuit breaker is actually a great system, and it could potentially be expanded to cover more conditions. I haven't learned why development of relay monitors stalled, but it could be a good failsafe as well. There's a recent post on ETH Research talking about how to harden external PBS, like MEV boost, through some changes to the builder specs and consensus behavior. Worth considering. But really, I think we should be prioritizing work on enshrined PBS, inclusion lists, MEV burn, and so on, things that'll help us eventually get relays out of the picture entirely. And a bit of a less developed idea, but it certainly seems to me that these attacks wouldn't be so bad if relays didn't have 60% to 90% of all validators connected. But maybe that's just the way it is. So with that, I'm wrapping it up. Thank you.
Well, I mean, they can quit out of it and the clicking will still work, but you're not getting that power. So I'm not sure if it is like connected with like your drivers.
Okay, no worries. I can stick to the podium. But it's not, yeah.
I mean, it's,
Is it quick for you to do, or
what?
in terms of like going into the settings?
Oh,
Primary.
we haven't been digging into anything's tech.
Yeah,
really.
yeah. That's smart.
You know, especially with this crowd, you know, like you guys are past us.
No worries.
But yeah, it does suck though. But that,
It might be because I'm not sure if the last person did like a PowerPoint or you downloaded a PDF version of their slides. I'm going from a URL from Beautiful AI. So
that's probably it. Yeah, we've had people doing like PowerPoint class.
Yeah. No worries.
Okay.
I can kill it from the podium.
Cool. So microphone here, and of course that is it's on and ready for you. Are you playing any audio?
No audio.
Just video. Cool. I'll just confirm that they're getting video. And then
Awesome. I'll kill it. Awesome. Thank you so much.
yeah, of course. All right. Can we configure your display? You're not getting video on ETHDenver.
Oh, how shall I do that?
So that would just be this I do know in your settings. It would just go to display. Let's see. We don't want to have a display. Without do you mind? Let's see. Display had been pulled up. We're just looking for the devices and the output correctly. Let's check that out again. Maybe I just missed it. Well, but that we should be seeing. Show up.
You can always try another port too, because my ports are over here.
Yeah, sure. Let's try that. That should show up as decimator. Oh, there we go, and that's the clicker. So if we go here.
That's the clicker, see?
Okay. Cool.
They should see it.
Yeah, let me see if we're getting video, and then I'll clear out.
And can I see the clicker as well to see if that works? Yeah. Okay, it does.
Amazing.
God is good.
Cool. We're good on picture? Have fun.
Thank you so much. Awesome. Hi, everyone. Today I'll be talking about use cases for AI ML in Web3 Infra. But starting off, my name is Jasmine Brunson. I am a data scientist, and my shadowy supercoder name is Bubbly Orca. And so you might be wondering, who am I? I'm a data scientist, a blockchain developer, and security researcher. I pivoted from GovTech a few years ago to go into Web3 full throttle. I found out about Bitcoin in 2016, watching the movie Dope. And I think that the future of Web3 is really in Web3 security, but also now that ChatGPT has been launched, there's been a lot of talks about integration between AI, ML, and Web3. So I'm going to talk about what's here, what's not quite there yet, and what I'm gung-ho about. And so the topic of discussion, we're going to be talking about different applications. Of course, these are not the only applications, DAO governance, oracles, zero knowledge, artificial neural networks, et cetera. But these are the things that I've been thinking about and what keeps me up at night. And then also what to look out for, right? We're looking at Halvening 2024 this April. And after every halvening, we see a Bitcoin bull run. We see a whole bunch of projects propagate. But now that AI is hot, we're going to see a lot of AI coins. So we're going to talk about the differentiation between which AI coins really have utility or might have utility and which ones are just shit coins. And then also, one of the most passionate subjects that I have in AI ML in general is ethical and responsible AI. Ethical AI and responsible AI. So we're going to get into that today. And so one of the major applications for AI in Web3 is the Oracle problem. Issues with data feeds, issues with inaccuracies of the data that oracles get. So at the end of the day, when we talk about trying to prime that data, making sure that data is accurate so the smart contract actually is working off of accurate data, AI does help with that. Also, the privacy piece and the data integrity is very important as well. And so going back to what I was saying about use cases, DAO governance is a major use case, right? Identity, making sure that we stick to the basis of data science, right? We have the relationships between one to many, many to many, et cetera, but you don't want in your DAO for one person to have multiple accounts so they can vote a duplicate amount of time. So ensuring that data and identity verification is on point is very, very needed and necessary. And then also with voting mechanisms as well. And so, funny enough, zero knowledge artificial neural networks is a topic that I was pondering one night, and I was like, why isn't this a thing, right? Why can't we integrate zero knowledge in artificial neural networks? That will fix the training data problem that we have with black box attacks, gray box attacks, and white box attacks. And then, instead of going on Twitter and saying I found out or I created zero knowledge artificial neural networks, I looked it up. And I came across an article by a man named Ross Ulbricht. Some of you all may know Ross Ulbricht was the creator of Silk Road. He is serving a life sentence in prison for his creation of Silk Road, which was a platform that went in straight disarray. And to make his right wrong, he had talked about the censorship problem when it comes to platforms such as WhatsApp, when it comes to platforms such as Telegram. And with that censorship problem, zero knowledge artificial neural networks can support with that. And also when we think about content moderation, content moderators from Facebook to Twitter, et cetera, they have to go through a lot of nefarious, harmful content, whether it be videos, whether it be images of graphic content. And that disproportionately affects people when it comes to mental health. So if we can leverage zero knowledge artificial neural networks when it comes to the censorship problem on platforms, then we can mitigate those problems when it comes to the human level. And then also, one of the most passionate subsets of this space for me is Web3 security. How we can integrate AI ML to detect smart contract vulnerabilities. How about the security researchers, the smart contract auditors, so they can focus on the more nefarious bugs and attacks, and those vulnerability detection tools can help us out with time and money. And just the future of smart contract creation too. Oftentimes we look at projects like ChatGPT and we say, hey, okay, we're gonna use ChatGPT to create a smart contract. Well, I would say, let's hold up on that, because a data scientist, a nefarious hacker can embed and do some data injection in that code that ChatGPT is querying, and you might suffer from a black box attack in the future. And so let me just start off by saying this is not financial advice at all, but AI coins are going to be a topic in the next couple of years. And I want people to kind of understand that not all AI coins are made the same. There are some AI coins that have been propagating before ChatGPT launched in 2022. So they might, in fact, have use case. But I just want people, especially noobs and people who are coming into this space for financial sovereignty, to know that not all AI coins are made the same. And some AI coins actually have utility. Gaming tokens, leveraging AI for tracking on-chain data data organization, prediction models, markets, et cetera. So going back to what I was saying, we're going to see a lot of AI coins in the next couple of years, especially with the Bitcoin bull run coming up. So I want people to be very, very keen and aware that it's going to happen, and we have to be smart when it comes to doing your own research. And so Web3 security. Here are a couple artificial neural network applications that I've been researching for the past 2 to 3 years. These are applications that can be attributed to phishing, DDoS, et cetera. And so MART2 is one where I've researched where that can be used for prevention of DDoS on blockchains. Tron is a blockchain that had a DDoS problem back around 2014, 2015. And DDoS can render your blockchain useless. So we don't want that when it comes to this space. Self-organizing maps, particularly, can be used for DDoS for L2s. Graph neural networks, degree-free graph convolution neural networks can be used for smart contract vulnerability detection. And then also self-structuring neural networks can be used for preventing phishing. So we've seen in the NFT run, there's been a lot of phishing attacks. When we look at Web 2, 80% of phishing attacks was distributed through email. When we look at Web 3, particularly in NFTs, the metric is similar, but it's not through email, it's through Discord. It's through Twitter. So these are some neural network applications that we can use. And pivoting from that, I just want to say that the Zen of blockchain, the Zen of Web 3, we talk about access, we talk about inclusivity, trustless systems, and there's going to be an overlap between AI and Web3 as we venture into this new space after ChatGPT has launched. And what I think about responsible AI is that we as scientists, developers, builders, we have an intrinsic responsibility to ensure that we identify the encoded biases in the algorithms that we create, and we also follow standards and assessments and create those standards and assessments so that we can have that access across the board. And so here's a couple case studies. There's a man named Dwan Buck, and he was put on death row. He was put on death row because a prosecutor in Houston said that because he was black, he was more likely to commit a crime. And that was based off a survey called an LSIR survey that leverages AI and ML. And some of those questions in that LSIR survey are like, how many times have you been pulled over by the police? How many times have you been convicted? Well, that is a direct relationship with racial bias that exists in technology. And so this is an extreme example of how weapons of mass destruction can lead to someone losing their life. Then we'll also talk about the invasive side, the privacy side. Target. There was a data scientist that was sitting down at his desk, and two marketers come up to him and say, hey, man, can you make an algorithm for me to figure out if someone is pregnant or not based upon pieces of text, cookies, right? The things they're looking on at the on their Target website. And he said, sure, I'll make this algorithm. And funny enough, a man one day goes into his home and he sees on the coffee table a magazine, and a Target magazine, and it's directed for his daughter. And his daughter is underage, but he's trying to figure out why is Target sending his daughter a magazine that has baby clothes, that has cotton balls for children. So he contacts Target and says, why are you sending this to my kid? And that's how he found out that his child was pregnant. And then also, recently, we've saw pushback with this. San Francisco has, they put out a bill to try to allow robots to work with police officers. Now, of course, they retracted that. They said that they came to the conclusion that it would disproportionately affect black and brown people. I mean, of course. But this is the direction that we're heading. If we don't slow down when it comes to this innovation with the security assessments and the standards. And so one of my favorite scientists, Dr. Timnit Gebru. She was ousted from Google years ago, and she spoke about the existential risks in AI, and people shut her out, and they didn't really listen to what she had to say because of the contentiousness of her being ousted from Google. But now she has an institution called DAR Institute where they're working very hard when it comes to the ethical AI and the responsible AI topic. And she says that scientists are some of the most dangerous people in the world because we have this illusion of objectivity. And so that brings me back to my case and my point. As we galvanize at ETHDenver and we build this tech, we also have to be cognizant of the encoded biases that we may or may not be propagating in our technology and in our creations. And so here are some book recommendations and also a Netflix series that I really liked, Coded Bias. If you guys have time while you guys are coding tonight, check out Coded Bias on Netflix. It's created by Dr. Joy, who is the next woman on the for this next book, Unmasking AI. She just launched that book, and I think it's super excellent. Also, Weapons of Math Destruction by Kathy O'Neill, Dr. Kathy O'Neill. She actually talks about the overlap, a little bit of the overlap of why we even exist in this space as crypto. She talks about the global financial crisis and how we had leveraged these machine learning algorithms to decide who gets this loan, who gets this house loan, et cetera, and then we see the economy collapse, et cetera. So there is kind of an overlap with the fluctuation of AI propagating and also the creation of our space, which is the crypto blockchain space. And I think that is like one of my most favorite books when it comes to ethical AI. And also Wired, they have this magazine talking about Timnit Gebru's story. And I definitely think that everyone should pick this up, find a PDF version, et cetera. But we are here in the future of how AI is integrated with a plethora of technologies, thanks to ChatGPT and the hype between large language models. Thank you all very much. My name is Jasmine Brunson. I also go by Bubbly Orca, and I appreciate you all for listening to my talk. Remember, don't get wrecked, get rectified.
Hey folks, that's the last event on our stage today. Thank you so much.